What if the sky never turned blue again? Not because the sun had died or the earth had vanished into shadow, but because the sky itself had changed. Because something older than memory stirred beneath our feet, reaching up with heat and hunger. Imagine a world where the horizon never truly sleeps, where even in the quietest hour, a soft, seething red hums just above the clouds. Not fire exactly, not flame, but something that glows slow and low, like the breath of a resting god. An ember sky, a planet shrouded not in darkness, but in endless volcanic light. And what if it wasn't just a dream? What if the world we knew had already worn such a veil? The earth is not still. Beneath our cities and forests and fields it moves, slowly, constantly, patiently. Plates slide, continents drift, and somewhere always something is melting. Subduction swallows the ocean floor into darkness, where salt water meets magma, and rocks begin to forget what shape they once held. Pressure builds, gases churn, and one day, not with warning, but with inevitability, the earth exhales. Not a single eruption or even 100, but an age of them, an age where the surface opens not in moments, but in epochs. When volcanoes don't just erupt, they rule. There are hints, of course, whispered in the rock, in layers of basalt stacked like forgotten books, each one written in fire. The Siberian traps, the Deccan traps, vast volcanic provinces, thousands of kilometers wide. Their very name, trap, from the Swedish for stairs, describing the way these ancient lava flows cooled and hardened in sweeping, stair-like layers. But maybe it's more than shape. Maybe they were traps in another sense. For time, for memory, for life itself. When these provinces erupted, they didn't merely paint the land in black glass. They changed everything. Oceans acidified, skies thickened with carbon and ash. The air grew heavy, the sun dimmed, and extinction crept through the food chain like a quiet fever. Some scientists believe the Permian-Triassic extinction, the Great Dying, was born of such fire. Over 90 of marine species gone, perhaps not in a day, but in geological minutes. And all the while, above, the sky glowed red. Not from one volcano, but from thousands, millions. A planet bleeding slowly through its skin. Not screaming, but sighing. We tend to imagine catastrophe as loud, as sudden. But deep time tells another story. It tells of collapse not as explosion, but as erosion, as silence, as heat that lingers, then stays. And maybe that's the most haunting part. That we might never notice the moment when everything begins to change. Because what would it look like, really, if volcanoes ruled? It wouldn't be a world of monsters and panic. It would be slow, beautiful, unsettling. The horizon would shimmer like a forge. The air, heavy with metal-sweet scent. Not death. Not quite, but a kind of forgetting. Trees would grow twisted, if they grew at all. Rain would fall thick and acid-soft, carving whispering grooves in stone. Oceans would warm, then boil, then bloom with strange, sulfur-loving life. New species born in heat, ancient ones vanished into ash. And above it all, that red sky, like the end of a dream that no one remembers beginning. Is it possible that such an age could return? That somewhere, beneath our foundations, a fuse is still burning? Maybe. Volcanoes are not dead. They are waiting. The Earth stores its energy not in minutes, but in millennia. And when it chooses to move, we remember how small we are. There are hundreds of supervolcanoes sleeping beneath the surface. Yellowstone, Toba, Campi Flegrei, each one a breath held, each one a memory buried in molten stone. But what if they don't erupt alone? There are theories, speculative, poetic, that the mantle itself can enter moods, that whole regions of the Earth's underworld can awaken in concert. Not randomly, but rhythmically, as if the Earth itself has seasons we do not yet understand. Could it be that we are merely living between them? And what would we do if that season came again? Would we understand the signs? Would we see the sky change and remember the stories of when it happened before? Or would we dismiss it as coincidence, anomaly, weather, History, after all, does not scream either. It whispers. And time, real time, deep time, moves like sleep. Slowly, irresistibly, quietly. And maybe that's why we forget. Because it is difficult to feel fear in the face of something so calm. Because a red sky is not an alarm. It is a lullaby, comfort, a warmth, until it isn't. And maybe we wouldn't run. Maybe we would simply adjust. Find beauty in the haze. Paint with ash. Dance beneath the slow flares of molten breath. Children would grow up never knowing blue. Poets would write verses to the forever dusk. And we would survive, not in defiance, but in adaptation. Just as life always has. Not because we conquer, but because we yield. And what a strange, gentle apocalypse that would be. Not with fire, but with glow. Not with thunder, but with hum. And maybe, just maybe, it's already begun. And yet, if this much can be lost, what else might we have forgotten? Perhaps we've forgotten that the earth is not a solid thing. Not firm, not still, but alive, in its own ancient rhythm. Breathing not like lungs, not like us, but through pressure and heat and time. Volcanoes are not accidents. They are not outbursts. They are not violence. They are breath. The slow, molten exhalations of a planet that has never fully cooled. Somewhere beneath the crust, deeper than the deepest mines, deeper than memory, the mantle moves. Not quickly, not noisily, but with the patience of eons. A slow churn, a restless stir. Heat rises from the planet's core in plumes. Vast, vertical rivers of molten rock, drifting upward through the solid mantle as if stone could flow like smoke. They are called mantle plumes, columns of buoyant fire stretching hundreds of kilometers wide, carrying with them the heat of a world that still remembers its own beginning. And above them, pressure builds. The lithosphere, the Earth's outer shell, floats like a cracked raft on this convecting sea. But it is not weightless. Presses, pulls, splits, and when it does, it makes way for breath. At mid-ocean ridges, tectonic plates drift apart. A slow unzipping of the seafloor. New crust is born, iron-rich and steaming, from the wounds of the deep. On land, rifts tear continents open, like Ethiopia's a far depression, where Africa slowly divides itself in silence. Not today. Not tomorrow, but soon, in the language of geologic time, in the scale where soon means millions of years, in the scale where a heartbeat is 1,000 centuries long. But what if the Earth doesn't wait? What if it sighs in places we don't expect? Hotspots, like those that formed the Hawaiian Islands, are reminders that plumes do not obey our maps. They rise even in the middle of plates, burning through from below like candles under ice. One after another, islands appear and fade, each born above the same breath, the same plume, while the plate glides slowly overhead. It's not the volcano that moves, it's the world that drifts. Could it be that these hidden rivers of heat remember something we don't? Could they be the memory of the planet itself, rising to the surface in pulses? Perhaps. Some scientists believe mantle plumes are anchored deep in the mantle's base, rooted near the core mantle boundary, a place darker and more mysterious than any ocean trench, a place older than bones. We cannot see it directly. We trace it through seismic waves, like echoes in stone, listening for patterns in the way earthquakes ripple through the planet. And sometimes, we find anomalies, places where the waves slow, linger, pool, as if something thick and strange waits there. We call them large low shear velocity provinces, LLSVPs, but the names do not explain them. They are not places exactly, more like shadows, more like dreams made dense. Is it possible that these anomalies breathe? Maybe not like we do, but in cycles, in flows, in heat that rises and cools and rises again. A kind of planetary metabolism, a rhythm older than the moon, a pulse we forgot how to hear. And maybe the Earth doesn't erupt to destroy. Maybe it erupts because it must, because entropy demands it, because heat cannot be kept forever, because even stone needs to release. So it gathers, beneath sleeping mountains, beneath our cities, beneath oceans. Magma chambers swell slowly, not with rage, but with inevitability, with the gentle insistence of thermodynamics. And sometimes, gases accumulate: carbon dioxide, sulfur dioxide, building pressure, changing chemistry, shifting crystals grain by grain. You would never notice, not from the surface, not in your lifetime, but over centuries. The breath deepens, and when the pressure grows too much, when the balance tips, then comes the exhale, but not always in fire, sometimes in steam, sometimes in the quiet release of hydrothermal vents on the ocean floor, where black smokers pour metal-rich water into the abyss, and life, strange, glowing life, feeds on the heat. Not light, not plants, just heat, just chemistry, just the breath of the deep earth, feeding something new. And isn't that strange? That from this furnace, life begins. That from heat, not light, comes animation. That even in the darkest places, the earth makes room for wonder. We are used to thinking of volcanoes as monsters, but maybe they are more like lungs, gentle when left alone, necessary, rhythmic, not to be feared but listened to, not because they are angry, but because they remember what we've forgotten, that the planet below is not finished, that it still changes, still grows, still sighs. And if that's true, if the earth still breathes, then what might it be dreaming of? Perhaps of futures we haven't lived, perhaps of shapes not yet formed, perhaps of eras when the crust itself shifts into something new, a supercontinent rising, or falling, a sea closing, or opening, a mountain range folding into dust, slowly, inevitably, without cruelty, without pause. And maybe, just maybe, the Earth is not only a planet but a process, a story told in heat, and stone, and time. And if the breath of the deep earth is part of that story, what else might be speaking through the rocks beneath our feet? Maybe it's the memory of something even older than fire, the slow motion of the world undoing itself. The way continents, once fused like puzzle pieces pressed tightly by unseen hands, begin to shift, not suddenly, not dramatically, but with a subtle persuasion that only deep time can apply. Rifting, not breaking apart in violence, but stretching, yawning, pulling gently until stone no longer knows how to hold itself together. Somewhere, far below where daylight can reach, the crust begins to thin. Molecule by molecule, its bonds weaken. Not from above, but from below, where heat wells upward like thought, like breath. The lithosphere, that outer brittle skin of the planet, isn't as firm as it seems. It floats atop the asthenosphere, a warmer, softer layer of slow-moving rock that moves not with speed, but with suggestion. And over time, this suggestion becomes insistence. It starts as a ripple, a bulge, a swelling from the heat of a mantle plume too patient to be seen, too ancient to be remembered. That heat pushes up, spreads outward, thins the crust, and something begins. A crack, a line, a quiet unzipping of the land. We call it rifting, but that word doesn't carry the time it takes. It doesn't carry the loneliness of a continent dividing from itself. East Africa holds such a memory. The Great Rift Valley, vast, slow, growing, is not just a scar, but a prophecy. A place where Africa is gradually peeling itself in two. One day, perhaps 10 million years from now, a new ocean will lie where now there is desert and plain. Not because of destruction, but because of movement, because heat kept rising, because the earth cannot help but reshape itself. But what if rifting doesn't happen alone? What if, like breath, it follows a rhythm? Could it be that the planet's surface breaks in cycles, long, languid pulses of opening and closing? Some geologists believe supercontinents, massive assemblies of all the Earth's land, come and go not by chance, but through deep, recurring forces. Pangaea was not the first, and it will not be the last. Before it, there was Rodinia. Before that, Nuna, a looping choreography of connection and separation, of formation and forgetting. And every time the land breaks apart, the deep earth answers. As plates pull away from each other, magma wells up to fill the void, like blood to a wound, but not to heal, to create. New crust is born in these rifts, young, raw, iron-rich, And with that birth comes fire. Volcanoes string themselves along the seams like beads, like punctuation marks in stone. Sometimes quietly, sometimes not. Iceland rests on such a wound. A place where the mid-Atlantic ridge rises above the waves, where the planet is pulling itself apart beneath snow and moss. But could it go further? Is it possible that a rifting event, stretched wide across a continent, could awaken something more? A planetary-scale eruption cycle. Not a single volcano, not even many, but an age of fire, where flood basalts pour across thousands of kilometers, smothering everything in slow, glowing sheets. This happened before. We see it in the scars left behind in the Columbia River basalts, in the Karoo, in the Parana, in the moments when rifting and plumes meet and linger, because when the crust is thin, the heat rises faster. When the plates pull apart, the earth breathes deeper. And maybe this is the heartbeat of catastrophe. Not in sound, not in speed, but in scale, in vastness, in the way the earth can change its own surface, not overnight, but all at once in geologic time. And still we live atop it. We build homes. We draw maps. We trace borders that mean nothing to stone. We forget how much lies beneath our feet, until slowly it rises. Could it be that some extinctions were not caused by a single impact, but by the long ache of a world dividing? Could it be that the silence after certain epochs was a silence born of too much breath? Too many volcanoes, too much carbon, too much warmth, oceans gone anoxic, skies heavy with ash, and no single moment to mark it, only the long unfolding of change. And yet, it's hard to fear something so slow. There is no thunderclap in rifting, only widening, only parting, only stone learning to become something else. And in that widening, new possibilities, new oceans, new patterns of wind and wave, new cradles for life. So we watch, we measure, we place GPS beacons on either side of fault lines and record their patient drift. Millimeters a year, centimeters if we're lucky, but it's happening. Always, beneath us, around us, the land shifts, the world exhales, and perhaps, if we listened closely, we could hear the next break beginning. Not in sound, but in rhythm. Not in rupture, but in release. And if the continents are still shaking themselves apart, what memories might be sealed in the pieces they leave behind? And if the continents are still shaking themselves apart, what memories might be sealed in the pieces they leave behind? Maybe the memory is heat. Maybe the memory is fire. Not the kind we know. Not campfires or candles, not wildfires that race through forests, but something older, slower, heavier. A fire that doesn't flicker, but floods. That doesn't rise, but spreads. Quietly, relentlessly, until whole continents are lost beneath it. Until time itself feels scorched. These were not moments. They were eras. Long, unfolding chapters when the earth seemed to forget how to cool. When deep rifts opened not for days or years, but for millions of years. And from those rifts the planet poured itself out. Not as rage, not as punishment, but as inevitability. We call them large igneous provinces. Lips, but that name doesn't carry the feeling, doesn't hold the weight. These were oceans of lava. Plateaus of basalt so thick they still press down the land today. They were not local. They were not brief. They were planetary events. Breath held too long. Pressure released too far. The Siberian Traps, a name spoken with soft reverence by geologists, as if the rocks still carry echoes of something sacred or terrible. 252 million years ago, near the end of the Permian period, this province of fire erupted. Not once, not even twice, but in pulses, in waves. For nearly 1 million years, lava spilled out from deep within the earth, layer after layer, until the land was buried beneath more than 2 million square kilometers of igneous stone. A surface rewritten, a memory smothered, and with it, life vanished. Over 90 of all marine species, around 70 of those on land, gone. Not instantly, not by meteor or quake, but by a slower burn. Gases rose, carbon dioxide, methane, sulfur. The sky dimmed, the oceans warmed, The water lost its breath, turned anoxic. Coral reefs collapsed. Forests thinned. Insects disappeared. Not because of fire itself, but because of what fire leaves behind. Atmospheric change. Oceanic shift. A gentle, inescapable suffocation. Is it possible that we are shaped more by what doesn't move than by what does? Could it be that the stillness left in the wake of lava is louder than the eruption itself? The Deccan Traps tell a similar story, though across a different age. Around 66 million years ago, near the close of the Cretaceous period, India was a drifting island, racing northward toward its eventual collision with Asia. But before that meeting, something rose from underneath. A plume, a surge, another memory from the mantle. The Deccan flood basalts erupted across western India in pulses, vast flows moving like night across the land. One flow alone is estimated to have traveled more than 1,500 kilometers. Again, not instantly, but with persistence, with patience. And once more, the sky changed. Some scientists suggest this contributed to the extinction of the dinosaurs. Not the asteroid alone, though that impact left its mark, but the combination of cataclysms. The cooling from the dust, the warming from the gas, the confusion in the climate, the long imbalance. Could it be that extinction is not always one event, but a conversation between many? Lips have occurred again and again in Earth's history. Not randomly, but cyclically, perhaps. A rhythm of release, a planetary exhale. Each time they shift the balance. Carbon isotopes in rock layers tell us the story. Sudden spikes, long declines, a signature of change, a trail of fire's shadow. The Paranatendica province in South America and Africa. The central Atlantic magmatic province before Pangaea broke apart. The Ontong Java Plateau, now hidden beneath the Pacific Ocean. Each one a buried memory, a reminder that the Earth holds fire not as threat, but as promise. Not because it wants to destroy, but because heat must go somewhere. And maybe there is beauty in that. In the idea that the planet has its own rhythms, that it reshapes itself not through chaos, but through cycles. That lava in its slowness is also a kind of language, one we haven't fully learned to read. Because what would we see if we looked closer at these flows? What fossils lie beneath them, sealed in time? What landscapes, what rivers, what forests were drowned, not erased but preserved in stone? Is it possible that fire does not forget, but keeps the past, held in molten glass, waiting to be found? There is still heat beneath us, still provinces forming, still rifts spreading. Iceland, far. The Campbell Plateau beneath the ocean near New Zealand. Places where breath gathers, quietly, slowly, and yet the land we walk feels solid, permanent. It is not. It is skin, and beneath it, memory glows. Could we live through another era like this? Would we notice the change in time? Would we sense the warmth before the sky thickens? Or would it feel like a distant summer, arriving one decade at a time? Maybe the danger isn't in the eruption, but in forgetting that it's happened before, in thinking that permanence is real, that landscapes don't change, that oceans don't drown, that air doesn't turn against us, but the rocks remember. They carry the marks of every era of endless fire, every sigh, every silence, every turning of the world's internal tide. And if fire has shaped the world more than once, what else might be shaping it now, just beneath the surface of our knowing? Maybe it isn't the fire we should fear. Maybe it's what follows, the quiet that drifts down after the roar, like breath after weeping. Not the word itself, but the weightless fall of it. Not because it burns, but because it settles, slowly, softly, without urgency, without direction, just descent, a sky full of it, a hush so wide it feels like the whole planet has gone still. Imagine it falling now, not in violence, not in chaos, but like snow, gently, persistently, a whispering veil of fine gray dust, born from the lungs of volcanoes and carried on winds that forget the names of continents. It doesn't choose where to land, over oceans, over deserts, over forests and cities and fields, each flake too small to fear on its own, but together a blanket, a memory, a silence. In large eruptions, the ash can rise high into the stratosphere, far beyond the reach of weather. Up there, it doesn't rain out in hours. It lingers, travels, like the breath of a world passed from one hemisphere to the other, wrapping the earth in a film of dust. And as it falls, things change. Ash is not dead. It carries the chemistry of what burned beneath it: silica, feldspar, iron, potassium, calcium, trace metals, and rare nutrients. What was once locked in stone becomes light enough to float, then gentle enough to land. And where it lands, it feeds. At first, it buries, it smothers, it silences the green, but in time it gives, because plants grow in what they are buried by, because new life often begins with forgetting the old. The nutrient cycles shift, nitrogen loops tighter, phosphorus clings to new roots, and the soil becomes strange, different, not worse, just rebalanced, just reimagined. The biosphere breathes again, but in another rhythm, another texture, as if the Earth's lungs had changed shape. And in the oceans, even stranger things begin. Ash doesn't sink like stone. It dances in the surface waters, where light still lives. Tiny glass-like particles, sharp and soft at once, carrying iron to parts of the sea that haven't tasted it in ages. Plankton bloom, not because they waited, but because they remember how to rise when fed. And as they rise, they feed others. Zooplankton, fish, whales, a chain reawakened by fire's ghost. Is it possible that some of the Earth's richest bursts of life have followed its darkest veils of ash? Maybe, maybe not. But there's beauty in the quiet after. When the air no longer roars but holds its breath. When the sun filters through a sky made pale by particles so small they pass through fingers like mist. Ash doesn't just fall, it lingers. It alters. It dims. Sulfates in the upper atmosphere scatter sunlight, cooling the world below. A soft, planetary twilight. Crops shift. Seasons blur. The sky itself forgets what color it was. Tambara, a year without summer. Frost in June. Snow in July. Not everywhere. Not evenly. But enough. Enough to remind the world that heat is a gift not given, but borrowed. That ash, though weightless, can press down on memory. And what of the silence? After the ash falls, there is always silence. Not the silence of nothingness, but the silence of change. Birdsong dims. Insects vanish. The texture of sound itself alters, muffled by dust, by soot, by sorrow, but also by possibility. Because from that silence, new voices emerge. New ecosystems. New beginnings. Not despite the ash, but because of it. Fossil beds like ashfall in Nebraska hold entire herds, frozen not in flame, but in sediment, their bones preserved where they fell, lungs filled not with heat, but with air turned to glass. A stillness that holds time in place. An extinction made gentle by how slowly it came. And still we forget. We forget that ash doesn't need to come from a supervolcano. It doesn't need to smother a continent. It only needs to fall little by little, to mark the world in ways that take centuries to read. Isotope trails in soil, layers in glaciers, rings in ancient trees, all whispering the same thing. The sky once turned gray, and stayed that way. Could it happen again? Maybe it already is. Maybe it always has been. Maybe the next great hush is already on its way. Not to end things, but to soften them, to blur the lines, to quiet the colors, to invite something new. And if ash can fall like snow, what else might the sky still remember how to release? Maybe it remembers rivers, not of water, but of stone. Rivers that once glowed and hissed and moved like liquid fire, and now lie still, cooled, hardened, but not forgotten. You've seen them before, maybe, on a quiet coast, in a valley no longer watched by fire. A strange, frozen wave carved into the land. Curled edges like black salt water suddenly stilled. Emotion stopped mid-breath. These are not rocks. Not exactly. They are memories in motion. The remnants of a time when the earth flowed. When lava first emerges, when it spills from a vent or breaches through a fissure, it moves with a purpose shaped by gravity, viscosity, slope. But once that purpose is spent, once the heat begins to leave it, it becomes something else entirely. A record, a surface that holds the memory of flow. As basalt cools, it doesn't smooth out like glass. Cracks, contracts, organizes itself, sometimes into columns, tall, hexagonal shapes that seem too perfect to be real. Like the earth is whispering in geometry. The Giant's Causeway in Ireland, Devil's Postpile in California, Fingal's Cave in Scotland, patterns repeating across continents, as if the cooling earth once dreamed the same dream in different places. Could it be that these shapes are the earth's way of writing? Not in letters, but in structure, in silence, in stone. A record not meant to be read, but felt, with footsteps, with fingertips, with stillness. And yet, these basalt plains don't only show how lava cooled. They show how it moved. You can walk a hardened lava field and trace the exact path it once took, like ghost trails left in blackened waves. Roped textures known as pahoehoe, formed when the surface cools faster than the lava below, folding and twisting like taffy made of glass. Or the rough, jagged AA flows, sharp, clinking rubble that breaks beneath your feet with the sound of ancient fire still echoing through it. These are rivers even if they no longer move. They remember the landscape they once crossed. They remember what they buried, what they shaped, what they erased. Could they remember us too? Maybe not by name, but by presence, by change, by the slight depression where a structure once stood, by the absence of something that had been there before. Lava does not discriminate, covers what it touches, but in that covering it preserves, sometimes fleetingly, sometimes forever, like Pompeii, where walls, bodies, and bread were held in place by ash and molten stone, sealed in the stillness of a single moment. But rivers of stone are not only witnesses to loss, they are also builders. Over time, they layer upon themselves, eruption after eruption, flow after flow, and in those layers a timeline forms, a stratigraphy of fire. Geologists read it like pages in a book. Each layer tells of a pulse from deep within, a chemical fingerprint, a shift in temperature, a subtle change in mineral makeup, traces of olivine, pyroxene, plagioclase, isotope ratios that reveal where the magma came from, shallow crust or deep mantle. Time can be measured here, not by clocks but by decay. Uranium into lead, potassium into argon. Every stone holds a secret half-life. And yet, these rivers are not only horizontal. Sometimes they rise, pile up, build new land. Entire islands forged in volcanic fire, then cooled into permanence. Iceland, Hawaii, the Galapagos, stone born from beneath the sea, rising above it, reshaping the map. Is it possible that continents, too, once began like this? That what we call land was once only lava? Maybe, maybe not. But even when the heat is gone, these rivers do not truly die. Cracks form, rain falls, lichens arrive. The slow touch of life begins again. Seeds nestle in hollows, roots explore fractures. Soil forms from what once flowed, and what was once too hot for breath becomes home. Entropy doesn't mean destruction. Sometimes it means change, a cooling, a rebalancing. A stone that once flowed, now becoming a bed for silence, for moss, for memory. Could that be what time truly is? Not a line, not a ticking, but a soft process of cooling, of settling, of remembering. The earth doesn't forget. It just slows down. And these basalt rivers, silent now, dark now, still now, are reminders of what happens when heat becomes history, when fire is not lost, but shaped, not vanished, but transformed. And if rivers of stone can flow, then what other impossible things might be hiding in plain sight, carved quietly into the bones of the world? Perhaps one of them is the sky. Not the sky we see now, open, scattered with stars, drawn in shades of blue and night, but another kind of sky. A sky that forgets to sparkle. A sky without stars. It doesn't happen all at once. It never does. First, the light changes. You don't notice it right away. The days still pass. The sun still rises. But something feels thinner, dimmer. Edges grow soft. Shadows fade. Colors mute. And then, when night comes, it doesn't arrive as darkness. It arrives as haze. You look up and see only the memory of constellations, blurred and trembling, as if they are trying to shine through smoke that won't move. When volcanoes exhale, really exhale, they don't just send lava across the land. They send particles upward, high into the stratosphere, far beyond the reach of clouds, far above the touch of rain. Sulfate aerosols, born from sulfur dioxide, scatter into the cold, dry layers of the upper atmosphere and begin to spread, slowly, globally. They don't fall. Not for weeks, not for months, sometimes not for years. And as they spread, they scatter sunlight. Not because they are dense, but because they are small. So small. Tiny crystals drifting through the air like glass dust. Invisible and everywhere. They scatter short wavelengths most. The blues, the purples, the very hues that make a sky feel infinite. And so the color begins to change. Pale blue becomes soft gray. Bright mornings become dull. Evenings linger in long, amber twilights that feel more like memory than light. Could it be that the sky remembers fire even when the land forgets? Maybe, maybe not. But we've seen this veil descend before. In 1257, the Samalas eruption in Indonesia sent so much sulfur into the stratosphere that the world cooled. Crops failed, rivers froze, and the stars faded. Not because they left, but because we couldn't see them. Tambora, in 1815, Krakatoa in 1883, Pinatubo in 1991. Each one left the air a little heavier, the light a little less sharp. Some eruptions dropped global temperatures by nearly a full degree Celsius. It doesn't sound like much, but the planet is delicate. The margin for balance is thin. What if it didn't stop? What if a chain of eruptions, like those during the formation of large igneous provinces, sent aerosols into the sky not for months, but for decades? Could the sky stay this way? Washed, diffused, glowing without shining, familiar, but far away. Perhaps we wouldn't notice at first. Just cooler summers, strange sunsets, a faint yellow tint to the moon. But in time, seasons would shift. Weather would stutter. Rainfall would move. Crops would strain. Ecosystems would tilt. And at night, as we look up, the sky would feel quieter, emptier. Is it possible to mourn the loss of something still technically there? The stars would still be above us. The galaxies would still wheel through the heavens. But we'd see them less, and less, and less, until they became stories again, not sights. Words passed down. Patterns drawn on paper instead of in the air. What if children grew up never seeing Orion's belt? What if the Milky Way was only a myth? What if darkness never returned fully, but never quite left either? There is something liminal about such a sky. Not night, not day, just twilight stretched across years. And in that strange glow, the earth would keep breathing. The aerosols would keep drifting. And still, above it all, the stars would wait. Even now, in cities lit by artificial suns, we've already begun to forget them. Light pollution steals more than visibility, it erodes relationship. The sky used to be our map, our calendar, our clock, our compass. Now it is a ceiling, soft, forgotten, pale with echo. Could volcanic twilight accelerate that forgetting? Maybe. And still we go on. We plant. We sleep. We dream under skies that glow with the soft hum of scattered light. And though we do not see them, the stars do not leave. They shine, patient, quiet, steady. In the upper atmosphere, the aerosols eventually fall, washed down by gravity, by time, by entropy. But while they remain, they do more than scatter light. They shape climate. They cool the world. A paradox of fire causing frost, heat leading to hunger, a breath that lingers too long. And all of this hidden in the sky, in the color of noon, in the silence of midnight, in the absence of stars. What else, then, lies above us? unseen, uncounted, shaping life below. Could it be that memory does not live only in the rocks beneath our feet, but in the air itself? And if the sky can forget how to shine, what else might we stop seeing before we realize it's gone? Maybe the answer lies below, in a realm that never needed stars to speak, in the slow-turning belly of the planet, where light does not reach, but time does. The ocean, not as surface, not as shimmer, but as archive. A deep, breathing vault where memory is not told in stories, but in isotopes, dissolved, dispersed, hidden in salt and current and silence. The ocean does not forget. It only buries gently. Volcanic winters begin with sky, with ash, with aerosol, with shade, but they end in water, because all things fall, even the finest particles, even the brightest smoke. Gravity pulls the memory down. Rain catches it. Rivers carry it. And the ocean opens its arms and keeps it. In the cold layers of seafloor sediment, clues sleep in thin bands. Ash layers, called tephra, lie pressed between centuries of dust and decay, a quiet punctuation mark in the slow writing of the sea. Some are thick, coarse, obvious. Others are so fine they can only be seen by measuring atoms. Traces of sulfur, traces of lead, ratios of oxygen that whisper how cold the water became, not because of the ocean itself, but because the sky had changed. Could it be that oceans remember the temperature of vanished air? Maybe. In the isotopic ratios of oxygen 18 and oxygen 16, we can see the fingerprints of ancient chill. Lighter oxygen evaporates more easily, so when the world cools and more water is locked in ice, the heavier isotopes remain behind. That shift, captured in the shells of tiny creatures, foraminifera, tells a story written in calcium carbonate. A story of breath held, of winters that lasted not months, but decades. And not all changes are gentle. Thermohaline circulation, the vast global conveyor belt of ocean current, depends on balance, on gradients of temperature and salinity. Warm water from the equator flows north, cools, sinks, returns in depth. But what if that balance were tipped? What if too much fresh water, too much melt, too much disruption shifted the rhythm? Could one eruption or a series of them stall the engine of the sea? We've seen hints. During the Younger Dryas, around 12,800 years ago, the world cooled abruptly. Some suspect a meltwater pulse. Others suggest a volcanic cause. The isotopic trails ripple through ice cores and ocean sediments alike. Signals that something changed. Something vast. Something fast. And through it all, the ocean did not speak. It simply kept. Salt trapped what the wind could not. Silt buried what memory left behind. Every layer a season. Every depth a longer pause. Is it possible that every volcanic breath ends in the sea? Not because the ocean seeks it, but because it catches what falls. Sulfur becomes sulfate. Iron feeds plankton blooms. pH shifts subtly. Carbon dioxide absorbed in silence. The ocean is not just a mirror of the sky. It is its inheritance. It's quiet air. And even life adapts to these changes. Diatoms, radiolarians, coccolithophores, tiny beings, drifting in the blue, record the chemistry of their moment. Shells harden or thin. Populations rise or collapse, not because of choice, but because of chemistry, because of memory made molecular. And we can read it, even now, in cores drawn from ancient mud, pulled from beneath kilometers of cold. Each centimeter 1,000 years, each grain a ghost. Could it be that the deepest truths about fire are written not in flame, but in water? Maybe, maybe not. But if we listen carefully, the ocean tells us how eruptions echo, how climate cools, how circulation bends, and how, even after the sky clears and the stars return, the sea still holds the echo, because the ocean is not a moment. It is a memory. A rolling, shifting, breathing chronicle of all that has passed. A place where entropy flows, but never ends. Where heat is stored. Where time dissolves into motion. And even now, somewhere in the deep, perhaps beneath the South Pacific or the North Atlantic, there may still be molecules drifting. that first fell from skies darkened by Tambora, or Toba, or something older, something forgotten. And if oceans can remember what the sky once hid, what else might they still be keeping, just out of reach, beneath the surface of our knowing? Maybe the answer waits in the dimness itself, not the dark of night, but the soft unlight that follows it. Pale world, veiled and hushed, where shadows blur and time loses edge, where sunlight does not disappear, but forgets how to shine. Volcanoes do not simply erupt, they exhale, and in that breath they change the sky. Sulfate aerosols, carried high into the stratosphere, become a veil that neither rains out nor breaks apart quickly. They linger, and while they linger, they bend the light. They scatter the blue. They reflect the gold. They cool the ground, and they dim the world. In 1815, Mount Tambora erupted with a force that reshaped the sky. A column of ash and gas rose over 40 kilometers high, punching through the troposphere, into the dry, stable stratosphere where weather cannot reach it. There it spread, thin, global, persistent. The result was more than local. It was planetary. A year without summer, frost in July, crops that never ripened, famines that traced no storm, but circled the globe like an invisible winter. And above all, the dimness. Painters captured it. Poets noticed it. The sunsets turned copper. The days dulled. The moon glowed red through haze, not because it was eclipsed, but because the sky itself had changed its fabric. And the stars, once again, retreated. But Tambora was not the first, and not the worst. Around 74,000 years ago, a far greater eruption shook the earth, Lake Toba, in what is now Sumatra. A supereruption, one of the largest in the last 2 million years. Its ash spread across Asia, dusted the Indian Ocean, and may have reached as far as Africa. Ice cores in Greenland contain its fingerprint, a chemical signature of absence. A moment in the sky, remembered by ice. Some believe the Toba eruption darkened the world for years. Others say decades. The cooling may have reached several degrees. Glaciers advanced. Rainfall collapsed. Plant life withered. Some models suggest that human populations declined, bottlenecked. A narrowing of our own story, traced not through fossils, but through the genome, where a sudden contraction whispers of something survived, but barely. Is it possible that we are all children of the dimming? Maybe, maybe not. But what if it didn't end? What if the dimming wasn't just an event, but a chapter? A turning of the world's breath, stretched not over a season or a year, but an epoch? Could the earth fall into a twilight that lingers, not by accident, but by rhythm? Volcanoes do not act alone. They move in patterns we don't yet understand. Pulses, clusters, ages of eruption, followed by long silences. And in those clustered times, when many mouths open, when many lungs exhale, the atmosphere becomes not just dim, but altered. Sunlight becomes diffused. Seasons slide. Crops fail not in one place, but in many. Migration patterns bend. Ice grows. And through it all, the stars are not seen. Is there a memory somewhere of a century without starlight? Not in books, not in words, but maybe in trees, in their rings where frost scars form, or in the shells of tiny sea creatures whose isotopes shift with temperature, or in cave deposits, speleothems, whose slow drip reflects the rhythm of rain and drought. A dimming leaves no single scar, but it does leave echoes, spread across archives of stone and salt and shell. Could we enter such a time again? Not as punishment, not as prophecy, but as cycle? The earth is not in balance. It breathes unevenly. It stores heat, then releases it. It builds mountains, then pulls them under. And sometimes, it forgets the sky is supposed to shine. And perhaps that forgetting is not cruel. Perhaps it's part of memory itself. To dim, to pause, to let light rest. Because in the dimness, other things awaken. Some seeds require cold. Some creatures bloom in dusk. Some ecosystems thrive on the edge of absence. And even we, slow, stumbling humans, have found our clearest thoughts beneath overcast skies. Some of our greatest stories are born not in brightness, but in shadow. And if the sky went quiet again, if the light thinned, and the warmth retreated, would we remember how to listen? Would we hear the trees shifting? Would we watch the ice advancing? Would we mark the sun's slow return? Not by date, but by color? Maybe the next great dimming won't come from one volcano. Maybe it will rise gradually, from a series of quiet eruptions, from deep beneath the oceans, from rifts in lands we forget to watch. And as the aerosols gather, we might not notice. Not at first, just a change in the tone of evening, a longer winter, a pause in pollination, a hush in the bees, and then the stars would begin to hide again, not because they were gone, but because we could no longer see through the veil. And if the world can be dimmed so gently, what else might slip away before we ever know it was here? Maybe it's not the sky we lose first. Maybe it's the moment, a breath, a step, a sound that never gets to echo. Because when the earth exhales not with fire but with silence, what it leaves behind is not always ruin, but a record. Perfect stillness, sealed in ash. We tend to think of fossils as slow things, bones buried over ages, pressed under layers, transformed by weight and water and time. But sometimes time skips. Sometimes it doesn't need eons to remember. Sometimes it takes only an afternoon. When ash falls fast, thick and hot and fine as dust, it doesn't just cover, captures. It wraps itself around the living world, sealing it in place before motion has time to flee. And in that sealing a memory is held. Imagine a forest, birds overhead, insects humming, a deer grazing near a stream. The air is warm, still, and then, somewhere far away, the earth opens. A column rises. A plume, dark and towering, begins to drift. The ash comes quietly at first, like strange snow, but soon it thickens. The sky darkens. The sound fades. The forest hushes. Leaves bend under weight. Breath slows, and then it stops. But what's left is not chaos. The stillness. Not because life never moved, but because it was stopped mid-motion. In places like Pompeii, we see this pause. Human figures frozen in the last things they ever did. Clutching, running, praying. But this phenomenon is far older and deeper. At ashfall fossil beds in Nebraska, entire herds of ancient rhinos, camels, and horses lie preserved not in bone alone, but in posture. They didn't just fall, they folded. Legs tucked beneath them, heads bowed. The ash filled their lungs before their bodies fell, and then filled the space around them. What remains is not just skeletons, but gestures. Stories of last moments held in place. Could it be that some parts of the earth remember us better than we remember ourselves? Maybe not our names, but our positions, our shapes, our endings. The preservation isn't magic. It's mineral. Volcanic ash is fine, angular, sharp. It settles fast and compacts tightly. Creates an anoxic blanket, no oxygen, no decay. Bacteria cannot work. Insects do not come. And beneath that ash, time changes its pace. Even leaves have been found, so delicate their veins are still visible. Even footprints, even feathers. In China's Liaoning province, volcanic sediments from the early Cretaceous hold fossils of birds and dinosaurs with such fine detail that you can see the layering of their plumage. Entire ecosystems locked in a blink. Fish caught mid-swim, plants still curled in budding. A dragonfly, wings open, stilled mid-flight, as if the ash arrived between heartbeats. Fossils like these aren't just records. They're interruptions. Is it possible that some of the best preserved moments in Earth's history are the ones where time was stopped, not passed? In New Zealand, the Taupo eruption left forests scorched but standing, their trunks encased in layers of ignimbrite. In Idaho, the Snake River Plain holds ghost trees, petrified not by flood, but by fire. Lava flowed so quickly it burned away the wood, but left hollow molds in the shape of what once stood. Absences, more real than presence. And perhaps that's the strange gift of volcanic preservation. It remembers not just the thing, but the shape the thing made, the void it left, the the space it filled. It doesn't just fossilize the body, it fossilizes the breath around the body. And in that breath we hear something more. Could it be that death and memory are not opposites, but partners? Ash makes time stop, not for all, but for some. And those moments become the most vivid, the most tender. A child of a trilobite caught in its mother's path. A small mammal curled in sleep. A fern, not crushed, but laid gently beneath powder. And yet, not everything beneath ash is lost. Seeds survive. Buried roots sleep until the weight lessens. Ash, rich in minerals, becomes fertile in time. So from the layers of death, life returns. Greener, stranger, wiser. Is that how the world rebuilds? By pausing, not breaking? By holding still so that something new can emerge? Entropy slows in ash. Decay halts. But eventually the wind returns. The rain, the roots, the fungi that thread through layers. And the fossil remains as witness. We read it now, carefully, layer by layer. Each fossil a phrase in a language we're still learning to speak. The isotopes in their bones tell us what they ate. The alignment of their teeth, how they lived. The trace minerals in their resting place, what the sky held when they fell. And all of it from a moment, not a year, not a century, just a single afternoon when the ash fell fast enough, thick enough, hot enough to turn breath into memory. And if a single cloud of ash can stop time long enough to preserve a world, what else might be waiting in the dust, just beneath the layers of what we think we understand? Perhaps a whisper, not loud, not even clear, just a breath left behind, a residue of survival, a question wrapped in stillness. Because once, and more than once, the world came close to silence. Not metaphorical, but real. An extinction so wide it brushed the edge of forever. The end-Permian extinction. They call it the Great Dying, but even that name feels too sharp for something so slow. It didn't crash into the earth like an asteroid. It seeped. It smoldered. It unfolded over thousands of years, maybe more. And yet, when it ended, more than 90% of marine species were gone. On land, forests collapsed. Insects vanished. The world held its breath, and for a moment, life almost let go. What caused it? There are clues. Not one, but many. But again and again, the trail leads back to fire, to flood basalts, to the Siberian traps, a volcanic province so large it defies scale. Not an eruption, but a geologic event. Lava pouring out for hundreds of thousands of years, releasing more than heat, releasing gases, carbon dioxide, methane, sulfur, not just into the air, but into the oceans. Warming, acidifying, breaking balance. Could it be that the greatest silence in Earth's history began not with destruction, but with a planet trying to breathe? Maybe not. But when that balance tipped, everything followed. The oceans lost oxygen. Anoxia spread across the seafloor. Whole ecosystems collapsed. Coral reefs disappeared. Trilobites, ancient, resilient, blinked out. And what survived did so in strange new forms. Small, simple, spare. Is it possible that survival chooses not the strongest but the quietest? The late Devonian extinction tells a different story, but echoes the same rhythm. A slow unraveling, spread over millions of years. Life faltering in waves. Again, the signs point to volcanism. The Vilui traps in Siberia. The melting of rocks, the release of metals, the rearrangement of chemistry. Black shales rich in organic matter tell of dying oceans, starved of breath. Isotope records shift. Carbon drops. The signature of something gone missing. And still, some life endures. In the shallow waters, armored fish fade. But the first forests rise. On land, early amphibians begin to crawl. Not in triumph, but in retreat. In adaptation, in the margins. Maybe that's the shape of resilience. Not expansion, but compression, a folding inward, a soft persistence when everything else is still. And what do the rocks remember? They remember it all, not in words but in patterns, in the sudden absence of fossils, in the thickness of ash beds, in the rare earth elements that trace the presence of volcanic glass, in the tiny details, shifts in calcium, spikes in mercury, that tell us something deep had stirred and the surface had changed. Entropy in motion, not chaos, just the slow release of order. Could it be that extinction is not the end of life but the end of a shape, the end of a way life was allowed to be? And in that loss, something else begins. The age of mammals follows the end of the dinosaurs. Ferns bloom after forests burn. Microbes rise when everything else has fallen. Life doesn't stop. It softens. It hides. It waits. And maybe it remembers. Not in memory the way we hold it, but in structure, in strategy, in silence. The fossil record isn't just bones. It's gaps. Voids where a world once was. And sometimes all that remains is a trace. A burrow, a footprint, a chemical ghost. These are not loud voices. They do not shout, but they whisper. And the whisper is this: the world has ended before. Not once, not twice, many times, but not completely. And always, something remains to carry the next breath forward. And if extinction can whisper from beneath stone and time, what other voices might be waiting in the layers we've yet to reach? Maybe they're the voices of opposites, of things that should not belong together but do, of forces we see as rivals, cold and heat, silence and eruption, finding one another in the deepest places. Because sometimes fire burns beneath ice, and sometimes ice listens. There is something almost mythical about it. A volcano hidden beneath a glacier, heat pressing upward, trapped under kilometers of frozen weight. No flames, no light, just pressure building in secret, just molten breath pacing beneath ancient snow. And when it moves, when it finally finds a crack, the eruption is not what we expect. It does not roar. It does not scatter cinders into blue skies. It melts, quietly, rapidly, furiously. It lifts the ice from beneath, turns solid into flood. They call them geological, glacier outburst floods, sudden, violent rushes of meltwater unleashed by volcanic warmth. Rivers formed in hours, strong enough to carve valleys, lift boulders, erase histories. Not because of rainfall, not because of storm, but because heat, hidden too long, had nowhere else to go. Could it be that some of Earth's most dramatic changes happen where no one is looking? Maybe, maybe not. But this union of ice and fire has shaped the world in ways we're only beginning to understand. In Iceland, volcanoes like Grimsvatn and Katla erupt beneath glaciers, sending pulses of water racing to the sea, reshaping coastlines in moments. In Antarctica, vast subglacial lakes form above buried volcanic ridges, warmed from below, sealed from above. And in Greenland, heat from ancient magma bodies still lingers beneath the ice sheet, altering the way it melts, shifts, slides. Volcanoes under ice do not just melt. They build. They form pillow lavas, rounded mounds that cool instantly when lava meets ice-cold water. They form tuyas, flat-topped, steep-sided mountains that rise only when eruptions push through thick glaciers and then stall, their peaks flattened by the weight of the overlying ice. A frozen plateau of fire, paradox in stone. And yet, it is not rare. During the last ice age, many volcanoes lived under ice. Their eruptions are hidden now, buried beneath layers of melt and time. But their signatures remain. In the chemistry of marine sediments, in the strange, bulbous forms of ancient lava flows, in the alignment of ridges that don't match any current terrain. Is it possible that some of the landscapes we walk today were born from this strange collaboration, shaped not by heat or cold alone, but by their quiet agreement? Fire, after all, softens what ice cannot break, and ice holds still what fire cannot contain. Together they rewrite mountains. Together they sculpt valleys. And beneath the sea, where icebergs drift above spreading ridges, where volcanoes hide along the ocean floor, their dance continues unseen. Steam vents rise, hydrothermal chimneys form, chemistry blooms in darkness, and life, strange and glowing, gathers around the warmth. Could it be that under the thickest ice, A second Earth waits? Maybe it's not land or sea, but something in between. A space where heat lingers just enough to keep water liquid. Where ecosystems live cut off from sun, from sky, from sound. We have found lakes beneath Antarctica, Lake Vostok, Lake Mercer, sealed under kilometers of ice, warmed slightly by geothermal flux. We have found microbes there, ancient and slow, not thriving, but persisting, breathing in a rhythm shaped not by seasons, but by pressure and time. And perhaps that's what this chapter really tells us, that extremes do not always oppose, that sometimes the most surprising creation happens when opposites meet gently, in the dark. When glaciers retreat, as they are now, they uncover more than stone. They awaken volcanoes long buried. The pressure lifts, the mantle stirs, magma becomes more mobile, and sometimes eruptions follow, not because the earth is angry, but because balance was disturbed, because something heavy was removed. And the ocean listens too. When ice melts, sea levels rise. When volcanoes heat the seabed, ice shelves thin from below. One speaks, the other answers. Slowly, quietly, together. Maybe ice is not an ending. Maybe it is a pause, a breath, a waiting place for fire to gather. Maybe every glacier remembers the warmth beneath it, and every volcano remembers the weight that once silenced it. And if ice and fire can conspire so quietly beneath our feet, what else might be shaping the world from inside the places we cannot see? And if ice and fire can conspire so quietly beneath our feet, what else might be shaping the world from inside the places we cannot see? Maybe it's something slower, something deeper, not a burst, not a crack, not a single moment of drama, but a long, low heat, a fever, not of the body but of the planet itself. Gentle at first, barely noticeable, a subtle warmth in the breath of the ocean, a slight haze in the sky, but growing, lingering, refusing to pass. What does it mean for a planet to run a fever? Not in the way we do, not from infection or illness, but from imbalance. From too much heat building up and too little released. From cycles pushed out of step. Volcanic ages, like those that formed the Deccan traps or the Siberian traps, don't end when the lava stops flowing. They echo. They persist. Through gases released, through carbon disturbed, through feedbacks that stretch across centuries. When volcanoes erupt in great numbers across long spans of time, they do more than shape the land. They exhale carbon dioxide, not in bursts but in breath. A steady release from deep within the mantle, carbon that had been buried, hidden, stored for millions of years, suddenly sent back into the sky. Not all at once, but enough. Enough to tip the balance. Enough to begin the slow fever. And the earth, in its own quiet way, begins to change. Oceans warm, currents shift, rainfall patterns stutter and slide. Ice retreats, and the albedo, the reflectivity of the planet, fades with it. Less light is bounced back into space. More is absorbed, and the warmth feeds itself. Not in fire, not in storm, but in a soft, persistent rising. Could it be that the earth doesn't rage but simmers? Maybe, maybe not. But in the fossil record there are signs. Times when oxygen levels in the oceans dropped. When anoxia spread across vast seafloors. When carbon isotopes swing in strange directions, marking a sudden release or a sudden loss. In the Paleocene thermal maximum, a moment nearly 56 million years ago, the planet warmed rapidly. Sea surface temperatures rose. Deep ocean acidity spiked. Carbon-13 levels plummeted, suggesting a massive input of light carbon. Maybe from volcanic sources. Maybe from methane clathrates, destabilized by that same warming. And all around species moved, shifted, faded. Could the earth feel its own imbalance? Not with nerves, but with patterns. With how heat moves, with how rock flows, with how carbon whispers its path through air, through tree, through shell, through sky. Volcanoes aren't only creators. They are regulators. They add to the atmosphere, yes, but in the long arc of deep time, they also set the stage for removal. As fresh volcanic rock weathers, it draws carbon dioxide from the air, locking it away again. Basalt binds with carbon. Rain and rock dance in a slow chemistry that cools the air, drop by drop. But that takes time. More time than warming often allows. So the fever rises, slowly, irresistibly, and in that heat, sea levels rise. Not only because of melt, but because warm water expands. A thermal swell. Coasts slip inward. Wetlands drown. Coral reefs, unable to adapt fast enough, begin to bleach. Some survive. Others do not. Life bends, but not always in time. And still, the world spins on. Greenhouse ages come and go. Cooling follows warmth. Warmth follows cold. The fever, like all fevers, breaks eventually. The carbon finds new homes, in limestone, in biomass, in deep marine sediments. Equilibrium returns. But not the same equilibrium. A new shape, a new atmosphere, a new world. Is it possible that each great fever leaves the earth with a different face? Perhaps this is how the planet forgets and remembers, through heat, through cycles, through rebalancing. The history of Earth's temperature is not a line, but a wave. An undulating breath shaped by volcanoes, by orbit, by tilt, by life itself. The carbon cycle is not passive. It's responsive. Living things influence it just as it influences them. Trees draw carbon down. So do shells. So do bones. But when the scales shift, when volcanoes add more than life can subtract, the balance drifts. And in that drifting, climates collapse. Not suddenly, but with the slow urgency of entropy, a system tending toward disorder. Not violently, just eventually. And yet, even in the worst of these fevered ages, something always survives. A lineage, a spore, a seed in the shade. Life contracts, simplifies, retreats, but it waits. And when the world cools again, it stretches upward once more. Maybe that's what we are, the children of a fever long since past. Maybe that warmth is still written in us. And if the earth can run a fever so quietly, what else might it carry in silence, waiting to stir the balance once more? Maybe it carries us, not us as we are now, walking, thinking, speaking, but as fragments, as traces, as impressions sealed in stone. What if we are not the storytellers, but the story left behind? Not the memory itself, but the fossil of a memory. Could it be that we too might one day become part of the archive? Imagine a future not measured in centuries, but in epochs. A world long after our maps have faded, our wires rusted, our languages unspoken. A world where forests grow through old skylines and oceans flow over buried machines. And beneath it all, far beneath, basalt. A dark, dense rock born of heat, slow and final, cools in silence. It hardens with permanence. And sometimes, it keeps secrets. What if lava found us? Not in destruction, but in preservation. Not in punishment, but in timing. A slow, roiling flow that blankets a city, that fills the hollow spaces of skyscrapers and rail tunnels and silicon labs, that presses down on glass, on plastic, on alloy, that captures the shape of our machines the way ash once captured the curve of a sleeping mammal's ribs. Could our artifacts, our engines, our circuits, our satellites fallen from orbit become part of the fossil record? Maybe, maybe not. But if they did, they would not fossilize the way bones do. They would not decay into mineral traces of calcium and phosphate. They would fossilize in another language, the language of alloy and polymer and composite. A stratum rich in strange isotopes, rare earth metals, elevated carbon signatures, anomalies, clues that something unnatural once stood here. Geologists call it the Anthropocene, the proposed age of humans. But what if the only evidence of that age becomes a single, buried layer of disrupted chemistry, trapped in cooled basalt, between two sheets of older, quieter stone? Would another intelligence, far in the future, know what it meant? Could they read us? Maybe they would find the shape of a smartphone, sealed in lava, its screen warped but its edges intact. A circuit board, delicate, intricate, like a coral reef of copper. A cluster of plastic chairs, fused into a single abstract sculpture. A turbine blade, strangely pristine. Would they see these as tools? or as fossils? Would they understand function? Or only form? Maybe they wouldn't need to understand. Maybe they would only wonder. And maybe that's all we ever do, really. Wonder about the past. The Devonian reefs. The Cambrian explosion. The basalt flows that swallowed forests before we were born. We don't remember those worlds. But we ask. We dig. We interpret. And maybe someone or something might one day do the same with us. Technofossils. A word not quite real, but not quite fiction either. Already, our mark is being etched into geology. Microplastics in sediments. Aluminum in layers where it should not be. Radionuclides. Synthetic compounds. Not everywhere, but enough. Enough to be seen by those who come later. If they come, could it be that our greatest legacy is not what we build, but what we leave behind? Not because we chose to, but because basalt doesn't ask permission. It flows, it cools, keeps, and under the right conditions, the right pressure, the right timing, a buried city might become a sculpture of itself. A trace, a ghost cast in mineral memory. Not because we mattered, but because we were there. Entropy takes most things. Water dissolves, air corrodes, roots break through, but basalt is stubborn. It is one of the few stones that can hold both time and silence. And perhaps that's what makes it a cradle for stories, even ones no longer spoken. What would it mean to be found? To be studied not as people but as data, as pattern, as anomaly? Would it mean we were remembered? Or merely discovered? Is there a difference? Perhaps memory doesn't need awareness. Perhaps being part of the Earth's long, slow layers is enough. Perhaps to be fossilized is to be forgiven. And if lava can seal the shape of a lost world in glassy stone, what else might it be preserving right now, quietly, beneath our feet? Perhaps a memory itself. Because stone remembers. Not in stories, not in words, but in presence, in pattern, in alignment, in trace. The Earth forgets nothing. It simply holds it differently, quietly, compressed beneath time and pressure and weight, but still there, still breathing, if not in air, then in arrangement. And what we call rocks might be closer to pages than we've ever known. A basalt cliff does not speak, and yet it holds a map of the sky. Every grain of magnetic mineral, tiny crystals of magnetite, aligned to the field that hummed through the Earth at the moment it cooled. A moment millions of years ago, when the planet's invisible shield pointed a different way, when the North Pole was not north and the South Pole was not south. And because lava locks that orientation in place as it hardens, we can read it. We can see where the field flipped. We can count the intervals between reversals. The last one was about 780,000 years ago. We don't know when the next will come, but the stones might know first. Is it possible that every cooled lava flow is a compass frozen mid-spin? Maybe, maybe not. But the record is there. Repeated. Reliable. Like a magnetic heartbeat written into solid earth. And it's not just direction that stone remembers. It's time. It's chemistry. The sequence. Layers stack, one atop the other. Like the slow geology of a thought. Sediment drifts, settles, compacts. What begins as dust or ash or clay becomes limestone, shale, sandstone. And within each layer, an isotope clock ticks. Not with seconds, not with minutes, but with decay. Uranium becomes lead. Potassium becomes argon. Slowly, predictably, a quiet countdown etched into atomic bones. Geochronology is not timekeeping in the way we know it. It's not about dates. It's about duration. About how long it's been since something changed, since a crystal formed, or a grain was last touched by sunlight. Thermoluminescence, fission tracks, the quiet scars of time on mineral skin. Could it be that stone holds a kind of patience we don't understand? Maybe that's what makes it so different from us. We measure time by what changes, the ticking of clocks, the movement of shadows. But stone measures time by what stays the same. By what endures, what resists, what only shifts under the weight of eras. There are rocks that remember the first breath of oxygen in the air. Banded iron formations, rusting red through layers of ancient ocean. There are zircon crystals older than any mountain, older than any fossil, older even than life, carrying traces of the water cycle from a time when the planet had barely cooled. They are 4 billion years old, and yet they remain, not because they are trying to remember, but because they never forgot. And then there are isotope trails, the fingerprints of atmosphere and ocean, shifting with each extinction, each eruption, each slow transition. Ratios of carbon-13 to carbon-12, spikes in sulfur, drops in oxygen, a signal embedded not just in the stone, but in the chemistry of the entire Earth. The past encoded in ratios, in deviations, in silence. Stone records the things we overlook. The way a glacier once moved across a valley, carving striations in bedrock. The pressure of an ocean that no longer laps there. The tilt of continents long drifted, faults sealed by time, veins of quartz filling cracks like scar tissue, not because the rock healed, but because it remembered how to stay whole. Even earthquakes leave their echoes in stone. Slips, offsets, slickened sides, polished surfaces along fault plains, burnished by millennia of microscopic grind. These aren't just structures. They're moments, fractures frozen in the act of breaking. Could it be that we are surrounded by memories all the time? Not memories of people or culture or thought, but deeper ones, slower ones, memories of warmth and cold and pressure, of atmosphere, of erosion, of the shape of the world before it had names. And maybe that's all memory really is, the arrangement of things, the way matter holds a moment, whether it's neurons or crystals or strata. Even fossils, those intimate fragments of life, are only possible because minerals chose to take the place of bone, to imprint shape, to mimic, to hold. And in doing so, they didn't just preserve form. They preserved loss. They preserved the space where something once was. Maybe that's what stone remembers best. Absence. Not because it wants to, but because it can. The earth does not keep a diary, keeps a record. And if you know how to look, how to feel the magnetic lines, how to read the isotopes, how to trust the layering, you can hear the planet's memory speaking. Slowly, softly, always. And if memory is written into stone, what else might the earth still be holding, deep beneath the surface, waiting for the right hands to listen? Maybe it's already inside us, not in metaphor, not in story, but in substance, in element, in the particles we breathe, the minerals we eat, the dust that becomes part of who we are. Because ash doesn't only fall on land. It falls into water, onto leaf, into lung. It settles into silence, but it does not stay still. Over time, over cycles, it moves, it seeps, it dissolves. And what once rose from the molten throat of a volcano becomes something intimate, something cellular, something we carry without even knowing. We don't often think of ourselves as geological creatures, but we are. Our blood carries iron, drawn from ancient stone. Our teeth grow from calcium once pulled from seas. Our bones are lattices of elements filtered through soil, fed by plants, lifted through breath and bloodstream and birth. And among them, there is ash. When volcanoes erupt, they scatter more than fire. They release fine-grained minerals, silica, feldspar, pyroxene, olivine, trace metals, crystals born in the dark. These particles don't just coat the ground. They become part of the cycle of life. Plants draw them in through their roots. Animals eat the plants. And so the chain continues, the chemistry of eruption woven, step by step, into the body of the world. Could it be that volcanoes don't just shape the landscape but shape the living? Not through destruction, but through quiet contribution. Maybe we find it in the teeth of mammoths, trace isotopes that point to ancient ash fields. We find it in fossilized shells, their structure altered by the chemistry of volcanic water. We find it in tree rings, marked not just by drought or fire, but by mineral imbalance in the soil. And we find it in us. Studies of human bones from ash-covered regions show elevated levels of elements like strontium, fluorine, arsenic. Sometimes toxic, sometimes beneficial, always present, always part of the story. Even our DNA carries faint echoes of environments long altered by volcanic breath. Places where nutrients surged after eruptions, supporting population growth, migration, transformation. And still we forget. Not because the ash has vanished, but because it blended in, disguised as soil, as dust, as air. But it's there, in the food we eat, in the water we drink, in the soil that grew the seed that fed the bird that sang to us once, long ago. Is it possible that each of us is carrying a fragment of eruption? A mineral fingerprint, a tiny crystal, once flung skyward, now part of the bone behind the eye, the enamel of a childhood molar, the iron singing in the blood. And if that's true, if we hold ash in our bones, then aren't we, in some way, archives too? The earth records its past in stone. But life records it too in the chemistry of survival, in the composition of bodies, in the choices of plants that thrived in altered ground, in the fish that spawned where hot vents fed the sea, in the species that evolved in volcanic cradles, near geysers and warm springs, nourished by what others feared. And maybe it's not just about what enters us. Maybe it's about what we return, because all things cycle, all bodies fall, and when we do, we return those minerals to the earth, to the soil, to the sea, and the process begins again. Ashen root, ashen bone, ashen rain, a long, slow spiral of sharing, not because we control it, but because we are part of it. Maybe the boundary between geology and biology is thinner than we think. Maybe we are not separate from the land we walk on, but continuous with it. Maybe to be alive is to be briefly assembled from the ingredients of eruption. Maybe the memory of volcanoes hums quietly in all of us. And if ash can live in our bones, what else might we be carrying, without even knowing it, from ages far older than our names? Maybe what we carry most is silence. Not the silence of emptiness, but the silence that follows something loud, something final, the stillness that arrives after fire has spoken, when the sky is pale with dust, and the earth is warm but no longer glowing, after the ash settles, after the lava cools, after the last tremble fades back into still rock. That is when the deepest quiet begins. The silence after fire is not nothing. It is not absence. It is breath held. It is potential waiting. It is the earth resetting its rhythm. A landscape paused. A canvas still smoldering with memory. Walk across it and the sound of your footsteps feels too sharp, too sudden, as if even the ground is listening now. At first, there is only black. Charred trunks, hardened flows, fields of ash that drift like dust but weigh like history. The plants are gone. The animals have vanished. Even the insects are quiet. What remains is not death, but delay. A kind of patience too deep for us to mimic. Pause written into soil. Could it be that silence is part of the cycle? Maybe not the end. Maybe not the middle, but a necessary stillness between destruction and return. Beneath the ash, seeds sleep. They are not dead. They are waiting. Fire does not frighten them. Some need it. Some cannot grow without it. There are plants, like lodgepole pine and eucalyptus, whose seeds are sealed tight until heated, until fire cracks them open, until the air clears and light returns. Then and only then do they begin. Life here returns not with drama, but with whispers. Moss threads its way across black rock. Lichens appear first, slow, soft colonizers that need no soil. Then the ferns. Then grasses. Then the first crooked stem, stretching up as if testing the air for change. Takes time, sometimes decades, sometimes centuries, but life remembers. The spores remember. The roots, buried deep enough, remember. Is it possible that fire clears the slate not for loss, but for possibility? Maybe, maybe not. But ecosystems are not erased. They are rewritten. Not all species come back. Some do, some don't. Some new ones arrive, carried on wind, on foot, in feather. And slowly, silently, the world becomes green again. But not the same green, a different one, tinted by what came before, shaped by heat, by chemistry, by change. The soil is richer now, charged with minerals from the ash, from the burned trees, from the melted stones. Phosphorus, potassium, iron. The leftovers of fire feeding the next generation. A strange gift, a quiet inheritance. Could it be that fire is part of how the earth remembers to begin again? We think of recovery as healing, as fixing, but maybe it's more like listening, observing, adapting. The land doesn't grow back in protest. It grows back in rhythm. It adjusts to what is not what was. The wind changes. The rain falls different. And still, the green comes. There are plains in Iceland where moss has blanketed lava flows so slowly, so delicately, that the rock beneath has almost disappeared. There are places in the Pacific Northwest where forests have returned after eruption, taller, denser, more diverse. But they did not return quickly. They returned quietly, in the time it takes for silence to become sound again. And in that time, the animals listened too. Small things first. Insects, birds, mice, then the grazers, then the predators. A web rewoven, a balance remade, not by force but by patience. Entropy never rests, but neither does renewal. They walk together, always. One clearing space, one filling it. Maybe that's why the silence after fire feels so sacred. Not because it's final, but because it's honest. It doesn't pretend to fix what was lost. It simply makes space for what might come next. And if silence can bloom across fields once charred, what else might grow from the places we thought were gone forever? Maybe something begins in the rain, not the soft, cleansing kind we wait for in spring. Not the summer rain that smells like soil and sky, but a different kind, a stranger kind. Rain that does not soothe, but etches. Rain that carries with it a whisper of sulfur, of chlorine, of something breathed from the deep. Rain that once touched the throat of a volcano. When magma rises, it brings more than heat. It brings gases, invisible, ancient, restless. Sulfur dioxide, carbon dioxide, hydrogen chloride. These don't fall to the ground. They rise. They drift. They mix into clouds already heavy with vapor. And then they fall again, changed, transformed into acid. Acid rain, a phrase that stings, a concept heavy with warning. But in the language of the earth, it is simply chemistry in motion. A natural reaction between breath and sky, not because the planet is angry, but because it is active. Because it is alive, and when this rain touches the world, it begins to rewrite it. Not in fire, but in dissolution. Stone begins to soften. Limestone pocked with invisible wounds. Marble loses its polish. Statues fade. Soil shifts. The rain seeps into roots, into rivers, into the bones of mountains. Carves not with force, but with persistence. With repetition. Over years. Over centuries. Not sudden, just slow. Could it be that even rain can sculpt the story of erosion? Maybe, maybe not. But there are places where the scars are visible, where volcanoes once changed the very texture of the land through rainfall alone. Downwind of Mount Pinatubo, forests yellowed in days. After El Chichon, the water turned acidic enough to strip leaves from trees. Vesuvius, Mount St. Helens, Laki. Each one left behind not just ash, but rainfall that etched the land in silence. But acid rain is not only an end. It is also a beginning, because what it wears away, it also feeds. The same acids that leach calcium from marble also free nutrients from rock. Phosphorus, magnesium, potassium, elements once locked in minerals are released, carried into the soil, carried into the sea. Fertilizers in disguise, and life, so often waiting in the wings, begins to stir. Is it possible that destruction and fertility are not opposites? That they are part of the same unfolding? We see it in forests regrowing on volcanic slopes, green even after acid rain has washed their canopies clean. We see it in lakes that go acidic, then clear, then bloom with strange new algae. We see it in soils that become more complex, more mineral-rich years after the last eruption. A strange alchemy, a long patience. Rain, even when caustic, carries memory. It records what passed through the sky. We can trace eruptions through layers of ice, where ancient acid rains left faint signatures, spikes in sulfate, dips in pH. The Greenland and Antarctic ice sheets hold these records like time capsules, trapped bubbles, crystallized clues, a map of storms long forgotten. Could it be that rain is how the sky remembers the fire? And if so, what else might it be carrying? Even in our bodies, traces remain. People living near active volcanoes often ingest minerals and metals from acidified rain, washed into crops, into cisterns, into breath. We drink the sky whether we mean to or not, and the sky in volcanic times is never neutral. But even so, life adjusts, not because it avoids the acid, but because it learns to live with it. Ferns that thrive in low pH, microbes that metabolize sulfur, trees that regrow from blackened stumps, fed by minerals freed from stone. In Iceland, in Java, in Kamchatka, places shaped by the breath of volcanoes, rain has always been more than water. And yet, the land is green. Maybe it is not the acid that matters, but how the world receives it. Maybe fertility is just what happens when destruction becomes generous. Maybe that is the balance, the slow release of what has been locked away, a kind of gift wrapped in discomfort. And if the sky can fall as acid and still awaken life, what other forms of transformation might begin in discomfort, hidden in the chemistry of change? Maybe it begins in blackness, not the black of night, but the black of beginnings, of something freshly born from fire, still warm, still glassy, still humming with the energy of its own creation. A field of black sand, stretching to the horizon, where nothing moves but wind, where nothing grows, not yet, but soon. Volcanoes do not just destroy, they create, not metaphorically but physically. They build land, real land, coastlines that didn't exist last year, plains that were ocean, hills that were only steam. And when the lava cools, when the ash settles, what's left is not soil, but potential. A blank page, written in basalt and glass. Could it be that life prefers the edges, the margins where nothing yet claims control? Maybe, because this is where it begins, in the cracks, in the fine grains, in the hollows of scoria and the ridges of cooling flows, in the places where the rock fractures just enough to catch a drop of rain. That's where the first green takes hold. It doesn't look like a forest. It looks like a whisper, a moss, a lichen, a thread of cyanobacteria winding through a crevice. The first breath of photosynthesis where once there was only heat. They come carried on air, on wind, on wings, spores from distant hills, seeds small enough to drift. Primary succession, that's what it's called. The beginning of an ecosystem where none existed before. Not regrowth, not healing, but first growth. Life building from nothing but stone and sunlight and time. In Hawaii, after Kilauea sends rivers of lava down toward the sea, the new land is sharp, black, shimmering, dangerous to walk on. But even there, especially there, you can find the first signs. Oichai trees, native and tenacious, rising from cracks barely wide enough for a coin. Their roots reach down through jagged basalt, splitting it further, pulling in moisture, stabilizing the future. In Iceland, moss carpets old lava flows so thickly it looks like a green tide frozen in place. Beneath that moss, new soil is forming, grain by grain. Could it be that the earth is never truly empty, only paused? Insects follow, ants, beetles, winged things, drawn by the warmth, by the hint of moisture, by the first flowers blooming against black sand. They find their niches. They find each other. A web begins to spin. Simple, fragile, but alive. Birds come next, then mammals, then more trees. But all of it, every step, begins with those first brave colonizers, the organisms that can survive without support, that can make something from nothing. They don't just grow. They change the land. They weather the rock. They trap organic matter. They create soil where once there was only glass. And still, it takes time. 100 years. Sometimes 1,000. But life is patient. Life is persistent. And so the black sand slowly turns green. First at the edges. Then at the heart. Maybe that's why it feels so sacred to walk across a new lava plain. Because you're not just walking on land. You're walking on memory in the making. What if this is how the earth dreams of life? Not in sprawling forests, but in the very first stem. The very first leaf. The first insect to land on a flower that didn't exist the year before. We tend to think of birth as a sudden thing. But planetary birth is slow. And often quiet. And it begins again and again in the same way with black stone. With heat turned solid. With the promise of fertility hidden inside ash. And if black sand can bloom into gardens, what else might be waiting in the places we've been told are barren? Perhaps it waits in the shape of silence itself. There is a kind of structure that only reveals itself after collapse. A vast hollow, ringed by remnants of what once stood tall. A crater not born of impact, but of emptiness. Caldera, the geometry of absence. To stand inside a caldera is to stand inside the memory of something larger. A volcano that erupted not upward, but inward. A mountain that gave so much of itself to the sky that it could no longer support its own weight. And so it fell. Not violently, but completely. The center caved, the flanks folded, and what was once rising sank. What remains is not a ruin. It is a form, a quiet equation of pressure and void. The scar of a planet's wound, drawn perfectly in the circle of stone. Could it be that collapse has a shape? Not random, not chaotic, but symmetrical, poised, beautiful. We see them across the earth, from the wide basin of Yellowstone, where geysers now steam from a fractured crust, to the collapsed crown of Mount Mazama, now holding the sapphire depths of Crater Lake, from Santorini's crescent ring of islands, tracing the ghost of a vanished center, to the Ngorongoro caldera in Tanzania, where lions walk through a crater so vast it feels like its own sky. And yet, these forms are not only earthly. On Mars, Olympus Mons rises taller than any mountain on our planet, its summit crowned with a caldera complex, layered with ancient collapse. Even there, in the thin air of another world, volcanoes lived. And even there, they broke. What does it mean that other planets also wear their emptiness in circles? Maybe this is how worlds process release. Not because they are broken, but because they changed. A caldera is not the end of a volcano. It is the mark left after it gave too much. After the magma emptied from its chambers. After the crust lost its footing. After the fire moved on. And what's left behind is not destruction. It is a map of surrender. Could it be that the Earth, too, remembers its losses geometrically? The floor of a caldera often steams. Hot springs pool. New cones sometimes form within it, smaller, watchful, quiet for now. Life comes back. Pine and lichen, waterbirds and wind. Rain gathers in the bowl. Lakes form where magma once churned. And still, beneath it all, the heat lingers. Sometimes sleeping, sometimes listening. And when it wakes again, it does so through the fractures, through the pressure points, through the radial cracks that spiral out like the petals of a stone flower. Calderas are not extinct. They are resting equations. They carry the geometry of entropy, the balance of force and void. They remind us that even the strongest structures can fold, not through failure, but through culmination. A collapse not of weakness, but of culmination. Of too much built, too quickly released. And still we walk through them, sometimes without knowing. The entire Yellowstone caldera is too large to see at once. It is a landscape, not a feature. A place where forests grow and rivers cut. And the skin of the earth still lifts and breathes a little every year. Scientists track its motion like a sleeping heartbeat. Not out of fear, but reverence. Could it be that the land itself has a memory of falling? Maybe that's what a caldera is. A reminder that even fire can overreach. That even mountains can empty. That release has form. And if collapse can leave behind something so symmetrical, so beautiful, What else might be hiding in the shapes we've mistaken for endings? Maybe it's not just here. Maybe we've only ever been reading one chapter in a much longer book. Maybe the language of fire, of eruptions, of ash, of renewal stretches far beyond this world, spoken not just by Earth, but by others. Cold places, distant places, moons that glow not with sunlight, but with something stirring from within. Because even in the dark, there is breath. Even in ice, there is motion. And even now, as we look out across the solar system, we find eruptions in the unlikeliest places. There is a moon that never rests. Io, circling Jupiter, is constantly being pulled and flexed by its massive parent and neighboring moons. It's a world of sulfur and fire, where volcanoes bloom like wounds across its surface, erupting fountains not of lava as we know it, but of molten sulfur and frozen frost. Bright yellow plains scarred by red and black pits, reshaped almost daily by forces deep beneath. Some eruptions on Io reach 300 kilometers high, higher than Earth's entire atmosphere. But there is no air to carry their heat, no wind to whisper through their steam, just vacuum, just silence, just fire in its purest form, rising through space, then falling back onto a surface that never cools long enough to forget. Could it be that a world entirely made of eruption is not chaos but balance? Maybe Io is not broken, but alive in another way. A place where pressure and pull perform a constant duet. A place where volcanoes are not anomalies, but the default. The surface never settled, never still. The entire moon a crust of cracking, pulsing heat. And then, there is Enceladus. Tiny, distant, icy, orbiting Saturn like a pearl lost in a ring of dust. On the outside, it appears quiet, white, featureless. But look closer, at the South Pole, and you'll find something strange. Gashes, deep in blue, known as tiger stripes, stretch across the surface, and from them, plumes erupt. Not lava, not ash, but water, heated beneath the ice by tidal friction, pulled and compressed, squeezed like breath through clenched hands. Jets of vapor, of salts, of complex organics, ejected hundreds of kilometers into space, falling as snow, feeding Saturn's outermost ring, whispering to the void. Could it be that life begins not in warmth but in hidden heat? Inside Enceladus, scientists believe there may be an ocean, a global one, beneath the ice, wrapped around a rocky core, and that ocean may be warm enough, rich enough, stable enough to harbor life. Not the kind we know, not with lungs or leaves, but with chemistry, with carbon, with patience. Could a world erupting with frozen breath carry the spark of something more? Maybe, maybe not, but the possibility lingers. And it's not alone. Europa, Triton, even Pluto, so many frozen moons, once thought dead, are showing signs of something underneath. Cracks that shift, ice that flexes, surfaces that do not match their age. Heat where there should be cold. Patterns of resurfacing. Quiet, slow volcanism. Not of molten rock, but of cryolava. Slushy mixtures of ammonia and water, flowing under alien skies. On Earth, volcanoes rise from rock. On other worlds, they rise from ice. Could it be that volcanism is not a rarity in the cosmos, but a rule? That the rhythm of interior heat and surface change is not an exception, but a heartbeat that pulses through moons, planets, and places far stranger than we've yet imagined? Even on Mars, silent now, the echoes remain. Olympus Mons, the tallest volcano in the solar system, 3 times higher than Everest, its base wider than the entire state of New Mexico. A sleeping giant. Its last eruptions may have occurred only a few million years ago, recent in geologic time, and its flanks are unweathered, as if it still remembers how to breathe. Could a volcanic age unfold on another planet? Right now? Maybe it already is, on a timeline so different from ours we cannot yet feel its pace. Maybe we only call them moons because we don't yet have the words to name them otherwise. And still, the pattern holds. Heat from within shaped by gravity. Crusts cracked by motion. Eruptions that shape a world from the inside out. Fire not only as destruction but as expression. If volcanic activity is a signature of energy, of possibility, of change, then perhaps the search for life is also a search for eruption. Not because life comes from fire, but because fire makes space for life to begin. Even now, plumes from Enceladus drift through Saturn's rings. We've flown through them, sampled their salt, felt their motion, and one day perhaps we'll land. We'll melt through the ice. We'll listen for warmth. And maybe we'll find that fire has been waiting for us too. And if the universe echoes with eruptions in frozen places, what else might be speaking in warmth we cannot yet see? Perhaps it speaks in stillness, because not all volcanoes erupt. Not often, not anymore. Some go quiet, some go cold. But even so, they are not gone. They are not lost. They are not dead. They are sleeping. Dormancy is a language we rarely hear, but the earth speaks it fluently. A language not of silence, but of suspension, a pause, of presence without urgency. Volcanoes do not follow human timelines. They rest in rhythms too long for us to recognize. Some slumber for centuries, others for thousands of years. Some go quiet for entire ages, then stir, slowly, gently, like a breath inhaled so deep it takes 1,000,000 years to rise. Could it be that patience is the true nature of fire? Maybe, maybe not. But there are mountains on Earth that once boiled with magma and thunder, and now cradle snow. Their craters filled with rainwater. Their flanks covered in moss, in forests, in cities. People build on their backs. Forget their names. We call them extinct sometimes, but extinction in geology is rarely certain. Beneath the roots of even the calmest peak, the mantle still moves, the crust still cracks, and magma still pools in chambers far below, waiting. Not in anger, not in haste, just waiting. Some volcanoes have paused for so long we've forgotten they were ever awake. Mount Nantai in Japan slept for 20,000 years before erupting again. Mount Vesuvius lay quiet for nearly 8 centuries before its catastrophic awakening in 79 CE. And in the western United States, the Long Valley caldera breathes faintly beneath a thin crust, monitored constantly, its last major eruption more than 700,000 years behind it. And yet, it is not done. Could a volcano forget it was a volcano? Or is dormancy simply a kind of remembering, a memory of movement held in still rock? Geologists speak of life cycles, of youthful shield volcanoes rising with easy flows, of stratovolcanoes that grow tall and steep, breathing ash and andesite, of old cones eroded to stubs, roots revealed, dikes and sills exposed like the skeleton of fire. But even these ancient remnants, mountains worn down by rain, by ice, by time, still whisper of their origin. They remember, in their shapes, in their chemistry, in the quiet scars that stretch beneath their skin. And sometimes volcanoes are born again, reactivated, fed by a new mantle plume, reawakened by shifting plates. The island of Réunion in the Indian Ocean rose from an old volcanic trail, the same trail that once fed the Deccan traps of India 65 million years ago. Time does not erase the fire, it only moves it. Could it be that every volcano is part of a longer breath than we can imagine? A global planetary exhale, paused mid-motion? Even under the sea, old volcanic ridges lie quiet, cold, dark, and yet, sometimes heat still seeps through them. Hydrothermal vents, low and steady, nourishing ecosystems that have never seen the sun. Even in dormancy, the warmth lingers. The earth rarely turns off its engines. It only shifts the volume. Dormancy teaches us something we rarely want to learn. That activity is not the same as being. That motion is not the same as purpose. That a volcano, even sleeping, is still part of the deep system that shapes continents, balances gases, drives cycles of life and carbon and air. The very ground beneath us is built by what used to burn, and what might burn again. We walk on the backs of giants dreaming. Maybe that's what mountains are. Dreams of fire held still by time. And when they stir, when the ground swells slightly, when gas begins to seep, when the pattern shifts just enough to feel, we remember. Not because we fear, but because we recognize that something deep and old is waking, not quickly, not violently, but with the slow intent of a system that never truly sleeps. And yet, if dormancy is not death, what else have we mistaken as lost when really it was only waiting? Maybe the answer is in the dust. Not the kind you brush from windowsills, not the kind that gathers in corners, but something finer, older, quieter, a dust so small you cannot see it fall, and yet, it never really stops. Dust born from fire, dust that outlives memory. When a volcano erupts, the world does not only shake, it breathes. It exhales particles smaller than any ash we can see. Tephra, ash, glass shards, crystal fragments, all lifted into the sky, caught in wind, drawn into currents, carried across oceans, across centuries. Some of it falls quickly, some never falls at all. It drifts and circles and lingers, suspended in the high stillness of the stratosphere, whispering across the planet. Could it be that the smallest traces of catastrophe travel the farthest? Maybe, maybe not. But we found it, volcanic dust, where we least expected. In ice cores bored deep into Greenland and Antarctica. In lake beds untouched by human hands. In peat bogs and permafrost and ancient glacier melt. Faint, microscopic lines like fingerprints pressed into time. Dust from eruptions so far away they would have seemed like myths, if not for the proof. In Iceland, a volcano erupts, and its ash lands in Scotland. In Alaska, a plume rises, and days later the dust settles in Japan. In 1815, Tambora darkens the world, and even in London the twilight turns copper. The sky remembers what the ground has forgotten. And not just the sky. Dust falls into rivers, onto leaves, into breath. We carry it in our bodies sometimes. Volcanic glass particles embedded in lung tissue, traced in autopsies, in pathology slides, in medical records left behind after eruptions like Mount St. Helens or Soufriere Hills. It doesn't always harm. It doesn't always heal. But it enters. It lingers. A mineral memory lodged inside something soft. Could it be that we are not just shaped by fire but dusted by it? That some part of us is always breathing the Earth's ancient exhalations? Volcanic dust is not inert. It reacts. It holds charge. It sticks. It seeds clouds, affects rain, influences chemistry in air and water. It carries trace metals, sulfur, iron, elements that feed plankton when they fall into oceans, that shift ecosystems, that tilt balances, invisible and yet everywhere. And it stays, because dust doesn't fade. It buries, it settles, it becomes part of layers, part of sediment, part of history. And when we study those layers, slice into cores drawn from the bottoms of alpine lakes or Antarctic shelves, we find it again and again. A layer just slightly different, slightly darker, rich in shards and splinters and strange little spheres. Cryptotephra. That's the name. Hidden ash. So fine it escapes the eye. So scattered it needs chemistry to be found. But once found, it tells us exactly when something happened. A timestamp from a distant volcano, embedded in a quiet lake halfway around the world. A geologic breadcrumb. A whisper of an eruption that no longer burns, but still reaches. Could it be that dust is the Earth's way of remembering what fire can no longer say? Some layers are older than civilization, some older than speech. Layers from eruptions we've never seen, never named. We find them anyway, in Japan, in Patagonia, in New Zealand, in the layers of soil that supported ancient crops, in the air pockets trapped in ice a mile below our feet, in the quiet breath of trees that grew in the shadow of what fell. Maybe we don't forget. Maybe we just stop looking, because dust does not go away. It is too small to disappear, too fine to notice, but it moves. It joins the wind, curls around the globe. It finds the low places, the wet places, the lungs of mountains and the veins of valleys. It rides the edge of entropy. Not order, not chaos, but drift. Endless drift. Even now, satellite images track plumes. Fine curtains of ash from volcanoes in Alaska, Chile, Kamchatka. We watch them in real time, gray threads unfurling across blue oceans. And even though they fade from the screen, they don't end. They continue. We may walk through them. We may breathe them in. We may one day study the sediment they leave behind in places we thought untouched. And maybe that's what legacy really is. Not monuments, not memory, but the smallest things. The dust that settles long after we are gone. The trace that endures not because it was meant to, but because it couldn't help itself. And if a single eruption can leave dust and ice for tens of thousands of years, what else might still be drifting from fires we've never known? Maybe it isn't drifting anymore. Maybe some of that heat never left. Maybe it sank instead into the crust, into the mantle, into the water itself. Not lost, but hidden. And maybe some rivers have never truly been cold, because deep beneath our feet, and far below the reach of light, the earth still burns. Not in flame, but in warmth. Quiet, slow, persistent warmth. The kind that moves through stone like breath through bone. The kind that feeds oceans from below. There are rivers we never see. They do not flow across landscapes, but beneath them. Beneath Iceland, where groundwater seeps into fractures warmed by ancient magma. Beneath Yellowstone, where entire networks of hidden streams rise to the surface as boiling springs and geysers, carrying with them the scent of minerals and memory. These are not just rivers of water. They are rivers of time, heated by decay, by friction, by pressure from within, fed by rain, shaped by stone, and carried upward by the deep exhale of a planet that never stopped dreaming. Could it be that warmth is the first language the Earth ever spoke? Hydrothermal systems are more than strange. They are precise. Fractures guide the water down. Heat pushes it up. The two meet somewhere in the dark, water and stone, fluid and fire. And when they do, something ancient happens. Chemistry awakens. Minerals dissolve. Reactions begin. And when the water rises again, it carries more than heat. Carries history. And sometimes, it carries life. On the seafloor, in places where tectonic plates drift apart, there are vents. Not cracks, but chimneys. Not smoke, but mineral-laden water jetting into the cold. Black smokers, they're called. Structures that rise like towers, building themselves from particles that fall out of solution the moment hot meets cold. The water here can reach 400 degrees Celsius. And yet, just centimeters away, it's near freezing. And in that narrow boundary, that impossibly tight line between fire and frost, life blooms. Not because of sunlight, not because of photosynthesis, but because of heat, because of chemistry. Microbes thrive here, feeding on sulfur and methane, transforming minerals into energy. And larger creatures follow, worms with no mouths, crabs with no eyes, shrimp with translucent shells. Entire ecosystems spun from heat, not light. Is it possible that life did not begin in warmth from above, but warmth from below? That the first cells stirred not beneath a sky, but beside a vent? We don't know, but we wonder, and we return again and again, through submersibles and sensors, to these hidden places. Because they seem to remember something we've forgotten, that warmth doesn't always mean surface. That rivers don't always run where we expect. Even high on volcanic plateaus, there are hot springs, pools that shimmer in blues and golds, rich with silica, with arsenic, with life adapted to extremes. Algae that thrive at the edge of boiling, bacteria that build layered mats, each color marking a different temperature range. Time moves slowly here, heat rises quietly, and the water is never still. Could it be that water remembers the warmth of the rock it passes through? Not in thought, but in chemistry, in taste, in touch. Geothermal rivers carry more than warmth, they carry signals. Ratios of isotopes that tell us how deep the water once traveled. Signatures of elements that mark the kind of rock it touched. And sometimes, ancient waters emerge, unchanged for thousands of years, finally rising again, warmed by the very breath of the mantle. Even now, engineers harness this heat, drill down into it, pull it upward, power homes, Warm greenhouses. But the source is older than any machine, older than our cities, older than our kind. And so the rivers run warm, hidden, soft with minerals and quiet energy, sometimes bursting into geysers, sometimes steaming gently into morning air, sometimes never surfacing at all, but tracing paths beneath mountains, beneath lakes, beneath our knowing. And if warmth can shape rivers in silence, what other stories might be unfolding just beneath the places we thought were cold? Above those unseen rivers, above the cooled fields of blackened basalt, above the roots of fire and flow, the sky waits. Thin, vast, delicate. The sky is not a dome, not a shield, but a breath stretched thin across the bones of the earth. It moves softly, quietly, but not without change. And sometimes, that change begins below. Beneath our feet, magma churns, pulling carbon from the mantle, sulfur from the crust, chlorine and fluorine from buried salt beds forgotten by time. When this molten body rises, it carries with it not just light and ash, but gases that the sky was never meant to hold. Could it be that the atmosphere is more fragile than we like to believe? We think of it as endless. We look up and imagine a cathedral of infinite blue. But in truth, the sky is thin, so thin you could drive through it in under 10 minutes, if only there were a road. The layer where we live, where we breathe, where weather dances and rain falls, the troposphere, is only a few miles deep. And that thinness is what makes it so easily broken. Not broken like glass, but broken like memory. Quietly, slowly, irreversibly. When volcanoes exhale, especially the colossal ones, the ones that rise not from mountains but from mantle plumes, from rifts, from the open wounds of ancient continents, they release more than we can see. Carbon dioxide thickens the atmosphere, trapping heat like a blanket pulled too tightly. But sulfur dioxide does the opposite. It rises higher, to the stratosphere, where it forms delicate veils of sulfate aerosols that reflect sunlight away. One gas warms, another cools, and both, paradoxically, are born from the same fire. What if the balance between them is always temporary? After the great eruptions, Tambora in 1815, Krakatoa in 1883, Pinatubo in 1991, the skies dimmed, temperatures dropped, harvests failed, ice crept quietly across the edges of summer. But not because the world had died, because the world had sighed. A single eruption, and the sky forgets how to be clear. For months, sometimes years. But what if not just one volcano erupted? What if it was an age of fire? We've seen it before in the pages of geological time. The Siberian traps, the Deccan traps, the Central Atlantic magmatic province. Events not measured in hours or days, but in centuries, in thousands of years of constant outflow, of gas upon gas upon gas. Long before humans walked upright, the sky was changed, not once but over and over, by pulses of heat rising from deep beneath the crust. Some of these pulses warmed the planet. Others, paradoxically, chilled it. The interplay between greenhouse gases and reflective aerosols isn't straightforward. It depends on altitude, on wind, on water vapor, on how long each molecule lingers before being pulled down by rain or transformed by sunlight. And so the sky becomes a battlefield of chemistry, invisible, silent, immeasurable to those who lived through it, but written later in ice cores, in isotopic ratios, in the rings of old trees and the shells of marine plankton that never saw the sun again. Maybe the sky doesn't forget. Maybe it simply waits. Thin layers of sulfate still sleep in the ice of Antarctica, telling us of summers that never came. Particles caught in polar snow carry the fingerprints of eruptions from centuries ago. We walk under the illusion of blue skies, not realizing that the past still drifts above us, in trails of dust, in shadows cast by clouds that no longer know why they formed. Could it be that even now the sky remembers what we do not? A single eruption today of sufficient size could lower global temperatures, affect monsoons, shift jet streams, blur seasons. And yet, the opposite could also be true. A pattern of smaller, more carbon-rich eruptions could warm us faster than we realize. The fragile sky is not neutral. It responds. It balances but delicately. Not because it is weak, but because it is precise. And what is precision if not vulnerability? The Earth as a system is vast, but not infinite, and its atmosphere is its most sensitive organ. A translucent lung, breathing in the breath of forests and cities and oceans and fire. What happens when that breath changes? What happens when it no longer exhales the same way it once did? We have numbers, yes, models, equations, simulations, but we also have gaps, forgotten gases, feedback loops we haven't found. What if the sky has secrets still unfolding? Maybe it is not just fire that scars the land. Maybe it is fire that scars the air. And if the air is so easily rewritten, so softly stirred by ash and gas, what else, above us, is waiting to be tipped? Beneath the sky's memory, beneath the ash that still hangs in ancient glaciers and the warmth that lingers in ocean vents, there are stories we cannot read. Not because they were never written, but because they were buried, silenced, melted, lost. Beneath layers of black basalt and frozen time, there may be cities, not of myth, but of dust and stone and breath. Civilizations that once rose to meet the sun, only to vanish into the soot-dark arms of a volcanic world. Not all disappearances come with warning. Sometimes they come with warmth. Imagine a people not unlike us, watching the moon rise over low hills, planting fields, singing under the stars. They knew the soil well because it fed them. They drank from springs fed by volcanic aquifers. They carved homes into soft tuff. They traced calendars across sunstones that marked the rhythms of eruptions long before science named them. They believed, perhaps, that the earth was alive, that it could think, that it could forget them. And maybe it did, because when the sky turned dark for a year or a decade, when the animals left and the crops stopped growing, when ash blanketed the rivers and the sun felt cold, what could they do but wait? Wait for the fire to pass, for the rains to come clean, for the air to turn sweet again. But what if it didn't? What if some never rose again? There are whispers in the archaeological record. Abandoned cities, collapsed trade networks, sudden cultural silence. Teotihuacan, buried beneath layers of volcanic debris. The Minoans, shaken by the explosion of Thera. The Harapans, gone before their ruins had time to weather. Not all of them were ended by fire, but some may have been erased by something slower, something hotter, something heavier than war. Could a city be entombed not by conquest, but by time's patient magma? When basalt flows, it doesn't move like fire. It moves like thought, slow, deliberate, unstopping. It pours across the land like honey in a dream, filling valleys, climbing over walls, swallowing streets. A single eruption might cool in days. A volcanic age might never truly cool at all. Layer upon layer, decade after decade, the rock builds up, not from destruction, but from creation. Not from explosion, but from expansion. Until the world above is gone. Until what lies beneath is preserved in silence. And if we cracked open those layers, if we peeled back the stone like pages in a forgotten book, what would we find? Pottery, beads, the curve of a doorway, a footprint in cooling ash, the final breath of a singer caught mid-verse. Not fossils, not quite, but echoes, preserved not because they were meant to last, but because the earth, for once, closed its eyes before it could erase them. We think of extinction as something natural, geological, but what about cultural extinction? What about the loss of memory not from death but from burial? What if entire histories were sealed beneath volcanic plains, their languages unwritten, their stories unspoken, their gods unnamed, not because they were unimportant, but because basalt does not care what it covers? Maybe that's the strangest part, that the earth can be both protector and eraser, that it can preserve a city in such detail that even fingerprints remain, but never tell us who those fingers belong to, that it can hold the shape of a wheel for 8,000 years, and still let the name of the people who made it vanish into dust. Is it possible we have already lost more than we remember? There are hints here and there, deep beneath flood basalts in India, where roads were found laid like bones. In the ghost outlines of stone circles beneath the Ethiopian highlands. In places where GPS says there is nothing, but seismic waves say otherwise. And what if some of them saw it coming? What if, in the slow rise of the Earth's fever, in the trembling soil and the scent of sulfur on the wind, some knew they would not survive? Did they leave messages, knowing we might one day return? And what does that mean for us? If basalt has buried others, could it bury us? Could our cities become technofossils, outlined in melted plastic and rare earth metals, preserved not in tombs but in tunnels, in satellites that fell to Earth, in skyscrapers cooled into monuments no one will ever climb? Maybe, maybe not. But what is certain is this: the Earth remembers differently than we do. It does not keep records, keeps layers. It does not tell stories, keeps shadows, not because it is cruel, but because it does not need to remember what it can always rebuild. And yet, if this much can be lost, what else might we have forgotten? Let me know if you'd like to continue with the next chapter or revise the tone further. And yet, if this much can be lost, what else might we have forgotten? There is something haunting in the idea that the universe prefers chaos. Not because it is cruel, but because it is inevitable. All things, no matter how precise, how symmetrical, how beautifully arranged, drift slowly toward disorder. A process so gentle, so patient, so complete, we rarely notice it happening. But in lava, it happens quickly, visibly, utterly. Here, in the breathless red core of a volcanic flow, entropy reveals itself not as violence, but as surrender. As heat rises, minerals that spent millions of years aligning, cooling, organizing into patterns we call crystal, quartz, olivine, feldspar begin to blur. Their structure begins to soften. Their bonds stretch and bend. Then, they fall apart. The symmetry is gone. The lattice dissolves. What was once memory, once shape, becomes liquid randomness. A molten forgetting. And in this forgetting, something new begins. The rigid laws of form melt into a shimmer. Solid becomes fluid, order becomes heat, precision becomes motion. The world does not burn apart, it flows. And maybe that's the most curious thing of all. That even as the world dissolves, it doesn't vanish. It simply changes shape. A kind of erasure that doesn't remove, but remakes. Could that be how the Earth writes its deepest stories? Not with permanence, but with transformation. Not because it wants to keep them, but because it cannot help but let them go. We think of lava as destruction, but that's only part of it. It is also one of nature's purest expressions of entropy, the slow unraveling of structure into potential. A boiling liberation from order. One that turns clocks into shadows and fossils into flame. Within its flow, time moves differently. Not forward, but sideways. Not linearly, but downward, inward, deeper into the Earth's open mouth. Maybe that's why volcanic glass is so mysterious. Obsidian, born when lava cools too fast for crystals to form, becomes something in between, a frozen moment of disarray. A solid that was once a liquid that was once a rock. Trapped within it is the record of a collapse. Not a collapse of land or city, but of certainty, of identity, a shard of what used to be, before entropy kissed it smooth. And what else dissolves in that heat? Is it possible that memory itself, if placed too near a vent, would soften? Would lose its edges? Could language melt? Could thought, once etched into clay or carved into cave, be erased not by hands, but by time and temperature alone? What is the half-life of a name when buried under 20 kilometers of cooled basalt? We like to believe that knowledge persists, that if we build it high enough, deep enough, bright enough, it will endure. But even the hardest steel yields to rust. Even the densest archives can be vitrified. A library, if swallowed by lava, doesn't burn. It liquefies. Pages do not vanish. They collapse into carbon threads, tangled and illegible, as if the words themselves have begun to forget they were ever meant to mean something. Not because fire hates knowledge, but because fire doesn't recognize it. Entropy is not a villain. It is a law. It governs not just destruction, but the direction of time itself. Why the future is always different from the past. Why memories fade, not sharpen. Why nothing lasts forever. Even the continents are subject to it. Their edges smooth, their mountains worn, their histories subducted into mantle, broken down molecule by molecule until nothing remains but isotope trails and chemical ghosts. So what happens to identity in a world of lava? What becomes of meaning when all structures, biological, cultural, mineral, drift toward randomness? If we were placed beneath the molten crust, if our architecture, our signals, our words, were exposed to that unrelenting heat, what would be left? Not monuments, not ruins, just trace elements, a smear of vanadium, a bloom of silicon, a whisper of gold. No stories, no context, no design, just echoes in the periodic table. And still, something waits in that silence. Because entropy, for all its hunger, does not devour everything. Some bonds are stronger, some traces too stubborn to erase. A magnetic alignment in cooling basalt, an isotope anomaly in a tephra layer, a ratio of oxygen that does not match the age it rests in. Little signs, little fragments, not enough to reconstruct, but enough to wonder. Could it be that even in total disorder, a pattern remains? Maybe entropy isn't the end of the story, but the beginning of a new one. Maybe what seems like destruction is only rearrangement. What if lava doesn't erase memory? It just hides it in another form. A code we don't yet know how to read. A history embedded in randomness itself. We often forget how young our understanding is, how thin the layer of time we call recorded. Beneath us, there are epochs that outdate language, layers that hold no names, formations shaped by forces too slow for human breath. There is a kind of comfort in that, isn't there? That we are not the first to face forgetting, that we will not be the last. And so the lava flows as it always has, downward, outward, quietly rearranging the known into the unknown. Entropy moves through it like a hymn, breaking, blending, softening, but not ending, never ending. And yet, if even lava forgets, what might the stars still remember? There comes a moment, after every long fire, when the world exhales, not in relief, but in resignation, as if the earth, having held its fever for centuries, finally remembers what it means to cool. The skies that once burned with sulfur haze begin to pale, not all at once, but slowly, as though the clouds are learning how to forget their own weight. And beneath them the basalt plains still smoke, their breath faint, their warmth distant, the last pulses of heat ebbing like tidewater through a body that no longer resists the stillness. The stone is black now, but not angry, not wild, just resting, just remembering what it was like to be magma, to flow freely, to reshape the shape of things. But the glow is fading, and the world, this fractured, scorched, stubborn world, begins to shift again, quietly into something softer. Maybe it doesn't happen in a day, maybe not in a year, maybe not in 10,000, but the change is certain. The way ash, once choking, becomes soil. The way acid rain gives way to gentle mist. The way color returns, so slowly, so shyly, to the land. Moss on stone, lichen on glass, a blade of grass finding purchase in a fracture line. Could it be that even in the ruins of fire, life hears a rhythm calling it back? The sky remembers too, its veil of volcanic aerosols, once thick with shadows, thins into a translucent breath. Sunlight, once broken into copper halos and eerie twilight, begins to soften at the edges. Blue returns, not a sudden flood, but a distant whisper. A blue like memory, like something almost forgotten, almost forgiven. And perhaps this is what a volcanic age looks like at its end. Not a triumph, but a gentle surrender. A long sigh, a final ember, not because the earth is finished, but because it has paused. There is science in the slow cool of basalt, a physics of heat loss, a chemistry of crystal growth, a gradual locking of minerals into time-stamped lattices, like pages in a stone-bound book. Isotope trails that whisper, this was once molten, and now it is not. oxygen ratios that remember the color of the air, trace elements that betray the secrets of pressure and depth. Every inch of cooled lava is a clock, not ticking, but remembering, and the ecosystems, tentative at first, begin to breathe again. Insects return to the silence. Tiny roots crack through glassy crusts. Wind brings spores from lands untouched. Rain, no longer acidic, begins to nourish instead of carve. Water pools in the hollows left behind. Birds trace new paths through air that no longer glows. Could it be that healing is not the opposite of fire, but its echo? The entropy of eruption gives way to a different kind of chaos, one that builds instead of breaks. Complexity from ash, pattern from randomness, not because life is strong, but because it is persistent, because it never quite stops trying. And somewhere, under layers of cooling basalt, under fused cities and swallowed forests, under libraries turned to void, the last heat lingers. Maybe for millennia, a core of warmth, unseen, still humming with the afterthoughts of eruption. Dormant, not dead, waiting, because volcanoes do not die. They only sleep. So what is this moment, then, if not peace? What is the quiet after the last plume rises, the last glow dims, the last tremor fades into silence? Is it an ending, or just an intermission in the planet's breath? Maybe it's both. Maybe the Earth is remembering who it was before the fire, and who it might become after. Maybe the glow does not disappear, but sinks inward, not extinguished, but folded away, like a candle covered by a hand, still burning somewhere deep. A whisper, a murmur, promise that the story is not over, because the basalt may cool, but the mantle stirs. The skies may clear, but the memory of sulfur lingers in the ice. The wind may soften, but the stone will not forget. And if this glowing age of fire can vanish so completely that all we see is a field of stone, cooled and quiet, then what else might we be standing on right now without even knowing it? What other fires have cooled beneath our feet? What other skies have burned? What other endings were not really endings at all? And yet, if even blue can return to the sky, what might rise next from the sea? What remains after the burn has ended, after the skies have cleared, after the silence has grown so deep it no longer feels like absence, but like the earth's final breath held in long, patient stillness? Not nothing. There is always something left. Not because the fire was kind or because the world was spared, but because memory is never truly erased. Not in the way we imagine. It lingers in fragments, in textures, in the orientation of crystals hidden deep inside stone. It lingers in the angle of ash grains pressed into ancient lake beds, and in the ghosted outlines of leaves that once fluttered, just once, before they were sealed by heat. Not stories, not voices, not names, but traces, quiet mineral echoes of what once moved, what once hoped, what once tried to grow. The earth does not mourn in the way we do, but it remembers, sometimes in layers so thin they cannot be seen, only inferred by isotope ratios, by shifted magnetism, by chemical fingerprints etched into sediment like secrets only time can read. Sometimes in silence, like a cathedral beneath the crust, a vault of forgotten warmth, and sometimes in the quiet arrangements of bones. Long after the fire has ended, there are fossils. Not whole, not always, but enough. Enough to suggest. Enough to make us wonder. Enough to hold a shape in stone that once held breath. What if that is the only kind of memory that ever mattered? Maybe the most fragile things, petals, feathers, spines, are the ones most carefully preserved in ash. Not because they are strong, but because they are still. Because they stop at just the right moment, and the earth, for reasons beyond knowing, wraps them gently in time, as if it too is trying to hold on. Could it be that the earth grieves in preservation, not because it wants to freeze life, but because it cannot bear to let it all vanish? And so it buries, it encases, compacts, layer upon layer, page upon page, until the record becomes unreadable to the eye, but not to the instruments of science, and not to the instincts of awe. Because even when we cannot see the shape of what was lost, we can feel its outline in the silence. There is a certain hush that lives in the post-volcanic landscape. Not the silence of emptiness, but the silence of aftermath. A silence that knows what came before and does not speak of it. A landscape that looks outwardly bare, but within holds every scream, every spark, every seed that tried to survive. It does not shout its history. It hums it, softly, low enough that only patience can hear. And in this quiet, we begin to notice things. The odd mineral blooming in cracks that once glowed red with fire. The way certain stones cleave along lines invisible to the eye, as if obeying old trauma. The strange chemistry of water that flows through old lava tubes, enriched by elements set free only by destruction. Even the air holds whispers, slightly different balances of carbon, oxygen, sulfur, shaped by events long past, still echoing in breath and breeze. Maybe this is what remains, the subtle, the strange, the half-forgotten, not just what was destroyed, but what was changed. Because not all survival is about persistence. Sometimes it is about mutation, transformation, becoming something new because the old was erased. Life, reshaped by ash, by heat, by hunger. Roots that now crave different minerals. Insects that nest in cooled glass. Organisms that never knew a sky before this one. And maybe we, too, are part of what remains. Our bones, our dust, our glass. Our synthetic traces left behind in caves and concrete and crushed machines. If we vanish, if time folds over us like it has folded over so much else, what fragments will linger? What molecular arrangements will suggest we were here? A buried circuit board? A plastic thread fused into basalt? A breath trapped in amber glass? Could it be that even we will become fossils in the ash? Not remembered, but recorded. Not known, but witnessed. And still the quiet deepens. The earth continues its slow rotation. Sunlight filters through thinner skies. Rains fall gentle over stone fields. The long work of erosion resumes, soft, steady, indifferent. Everything eventually becomes part of something else. That is not loss. It is the law of time. And so we find ourselves here listening. Not to what speaks loudly, but to what is barely there. We look to the rock, the dust, the frozen core samples pulled from glaciers, and we ask not what happened, but what remains. And in that question there is wonder. There is always wonder, because even in the quiet, the world is telling stories. Not in words, not in sounds, but in signals, in rhythms, in the gentle sway of a tree that took root in soot. In the shape of a cliff eroded by acid rain turned sweet, in the direction of a fossil's gaze. And yet, if this much can be remembered by stone, what might still be written in the sea? And if the sea can remember in silence, maybe the sky can, too. Maybe we can. Maybe we already do. There are breaths the earth takes that span more than a single lifetime. They come not as whispers, but as roars. Yet so slow, so vast, so wide, that from where we stand, we mistake them for permanence. They stretch beyond dynasties, across extinctions, past the collapse and flowering of languages. And when the earth exhales, not wind, but magma, not steam, but continents splitting, what does it mean to be here, in this moment? What does it mean to witness the planet breathing fire? Not metaphor, not myth, but heat, real heat, pushed up from the planet's mantle in pulses of pressure, in tides of stone. Not fast, but inevitable. Not sudden, but ceaseless. And if we lived long enough, if we could measure our years in millions, perhaps we'd see that this breath is not a beginning or an ending, but part of a larger rhythm. A planetary inhale and exhale of creation and decay. We are here for only a blink. But what if, in that blink, the fire returns? Maybe it already has. Maybe it never stopped. There are regions, today, where the crust thins like old fabric, where molten rock quietly pools, rising millimeter by millimeter toward the light. There are flood basalts asleep beneath our cities, rift valleys that tremble in their sleep, calderas that watch us like open eyes. We build roads across them. We forget they are alive, but they are. They are not dead, only dreaming, and sometimes the earth stirs, not with violence, but with the memory of heat. You can feel it in certain places, can't you? In sulfur springs, in the warm breath of geysers, in the glassy sheen of obsidian cliffs. These are not accidents. These are signs, quiet ones, ancient ones, telling us without sound that the fire still waits. Could it be that in our short flicker of existence we were born in the pause between breaths? And if so, are we closer to the inhale or the exhale? It would not feel sudden. It would not feel loud. First, the temperature might shift, by degrees we do not yet notice. Carbon dances higher in the sky and we call it a trend. Ash appears in polar ice and we call it ancient. Ocean currents drift into new configurations, whispering warnings we can only measure, never feel. Then maybe a single volcano, a minor event, local, short-lived, but beneath it pressure builds like memory. Layers of molten intent pressing upward, seeking fracture, seeking release, and we go on. We build, we breathe, we forget, not because we are foolish, but because we must. Memory is heavy, history is long, and fire, when absent, feels like myth. But the rocks remember, the isotopes know. They carry the record not of stories, but of cycles, of eras, of fire-struck decades and sulfur centuries, of skies that dimmed not once, but often. And though we think of ourselves as modern, unique, new, the Earth sees us as recent sediment, a layer not yet compacted, a residue of tools and concrete and lights, technofossils, future strata. If the Earth were to breathe fire again, truly, fully, like it did in the Deccan Traps or the Siberian Dark, would we know it for what it is? Or would we measure it in economic terms? In quarterly losses? In the price of wheat? Would we notice the sky dimming before the stars disappeared? Would we mark the snow that fell in summer, the silence of vanished birds, the bitterness in the rivers? Or would we call it anomaly? Could it be that a volcanic age could rise again, and we, in all our instruments and networks, might still miss the first breath? And if not us, who would remember? Perhaps satellites would record it. Seismographs would draw its first whispers in jagged black ink. Climate models would shift into panic. And still we might not understand. Not yet, because understanding comes slowly, like erosion, like grief. But the fire would come anyway. It has before. Not to punish, not to destroy, but because the planet breathes, and breathing is life, and life is never still. And in that moment, if it came, what would we leave behind? Not monuments, not headlines, but traces, ash sealed in glacier ice, glass formed in fields of former homes, fossils of cities buried beneath waves of stone, not to be mourned but to be found. By what we do not know. Perhaps nothing, perhaps no one, or perhaps something that reads our silicate records like we read the trilobites. Maybe our presence will be measured in isotopes. Maybe we will be a layer with strange chemistry, with new plastics, with artificial alloys, with words etched into carbon that no longer has context. And still the earth will turn. Still seeds will germinate, in cracks between basalt, in pockets of warmth that the fire left behind. Life will begin again as it always has, not where it should, but where it can. And it will not remember us, not with names, not with stories, but with the minerals we added to the soil, the shadows we cast in the sky, the warmth we tipped into the atmosphere, like a fever that never quite broke. We will not be the first species to change the sky. We will not be the last, but we may be the only one to know it was happening. And maybe that is the tragedy, or maybe that is the gift. Because to witness, to truly witness, a world in the act of becoming something new is rare. And we are here, now, breathing, watching, wondering, awake in a moment when the earth may be gathering itself again, preparing for something not yet born. We were here when the earth breathed fire, and we may be here when it breathes again. But what will we choose to see? And what softly, slowly will we leave behind?